if you think at call time, it is important to define the variable names, but it has one problem, that you need to know exact variable names. If the variable name is C1 there, you need to know what it's C1. You need not to, I mean, the C1 matches with C, it must match with C1. C2 must match with C2 and so on. So you need to know these names. Okay, great. In the upcoming videos, more features of functions are going to be discussed. So stay with us. Hope to see you in the next video. So in the last video, we saw the ordering of input arguments in a function. And we saw a fix to it. I mean, if there is a chance that you may miss a proper order, there is a way to fix that. We saw that in the last video. Here we have another thing to discuss. This x variable, x input argument, this is the variable that is defined inside a function. Although the value it receives is copied from somewhere else, but it is defined inside the function. That is also the function variable, or the variable that is in the scope of the function, inside the function, in the body of the function, something like so. It may be handy, for example, let's say you compute something, you do some processing on your inputs, and whatever the result is, you save that result in another variable. And let's say now you need the value of this variable to do some further process. Let's say what you do is, let's say at the call time, let's say this is the function. Let's say this is the complete function, and let's say a is equal to 12 and b is equal to, let's say, 7. And let's say you call the function add a b. Now the value of a will be copied in x, the value of b will be copied in y. Okay. And now you need the sum of a and b to be received here in a variable. You want a variable in which the result should be saved. For example, let's say the variable is d, let's say. And then you want to do some more processing on d, let's say d double star 5 mod 3, and maybe you need to apply an if condition on that. If that equals to 0, then do some stuff otherwise. So let's say you need this variable out. What will happen is this c variable is not accessible outside this function, and the reason is the c is defined inside the function. When the function body completes its execution, the c is lost. C is no more available. C is defined when the function call has been made. When you are executing this statement, C is defined, and a memory location was created in a C, sometimes called the function space in the memory, or process space, that is created in memory. But once all the body of the function executes, all the functions that were inside the variable, they are lost. How can you receive this value? How can you receive the value inside C outside this function? So that is question in this slide. How can we do that? Further, this particular function can access all the variables that are not defined in this function, but that are available outside this function and are defined already. For example, let's say I have a function f, and the function is, let's say I have a function f, and so if this function is defined like so, f, let's say f is your function, and it is defined like def, and that's it. And here it prints, let's say, some variable, let's say a. Let's now this a variable is no longer in f, not even defined in f. But as long as this a variable is defined before calling f, for example, that's the cell where we are writing the code, and we say, okay, a is equal to 7, and then we just call this f. Because a was available before calling f, a is accessible here. So the functions, the variables that are available before the call, they are available inside the functions. But the variables that are defined inside the functions, they are not available outside. That's a problem. Further, if we define this a here, a is equal to 2, Now this a is sometimes called the local variable or the function variable, the variable that is local to the function. Now this a is defined inside the function, and all the accesses to a will access this value 2 rather than the 7. Consider the 7 has a separate location in memory and this 2 has a separate location in memory. Both have names a, but this a will only be referred to when the function is executing. After the execution of the function completes, this is gone from the memory, and this will still be available. This 7 will still be available. So it is good to know. And by the way, if a was not defined here and you still called f, then either you will be getting an error, or this a might be a global variable or available in some package that you have already loaded or stuff like so. In that case, this a will be accessed if it's a global variable or accessible. So it is good to know the scope of the variables inside the function, because when you're calling them, what functions, if x is already defined, for example, if x is already defined like 34, and then this x is 34 as long as this x is not defined here. If x is defined here, this x actually is the local copy, and that will be accessed inside the function. Once the function is gone, again x will be 34. So it is good to know the local copies or the function space itself. But the problem here is how to access this variable, the value of this variable outside the function, because this is completely defined inside. How to access that? Well, there is a fix, and that fix is called the return statement. If you write the return statement, for example, you return this value, so x plus y. You might have saved these values. You might have saved these values, for example, c equals x plus y. That's okay. And then you say, okay, return c. What will happen is wherever you have called this function d equals add, let's say 2, 3. Now this value c, which in this particular case is 5, that value will be returned in d. And all the properties of this variables are returned in D. So just like this C is copied in D, and this is available further, whatever you want to do with this D. Okay, so yeah, so return statement is there. So in the next video, we will actually code this in Jupyter Notebook and see the return statement running, and we will see the scope of the variables and all that in Jupyter Notebook. So hope to see you in the next video. In the last video, we saw scope of a variable, particularly if a variable is defined inside a function, is it accessible outside the function? And if a variable is defined outside the function, is it accessible inside the function, and vice versa, and so on. So we discussed those kind of things, which is sometimes called scope of a variable. And further, we discussed what if we want a value of the function that is computed, value of some variable or some result that is computed inside a function. What if we want that to be accessed outside the function? So we discussed that in detail in the last video. So let's see all those concepts in a running form in Jupyter Notebook. So let's see how it works. So first of all, let's define a variable. Let's define a function. Let's say define, let's say my add, and let's say it receives 2 arguments. Let's say a and b, and then let's say c is a plus b. Let's say that's c, or c value. Let's say c value or some value, whatever you want to call that value, some value. That's it. Let's say we did that. Now we want to access that some value from outside the function. Print some value. By the way, let's first call this function. Let's say my add for values, let's say 2, 3. So 2 will be copied in A, 3 will be copied in B. So then let's try to access this value, some value. It will throw an error, and the reason is this variable sum value is not accessible outside this function. What if we want to access, because this is defined inside the function, what if we want to access this, what if we want to compute some result and then use that result outside the function? So the way out, as discussed in the last video, is return statement, return value. And now if we call that again, if we call that again, now we haven't actually registered. By the way, remember this, that's a common error I got in that error many times. If you change the implementation of the function, you have to rerun that cell. You have to register the updated copy of the function to the Python. Otherwise, you will be getting errors, probably. Yeah. What's the problem here now? Print sum value. This sum value is still not accessible, because sum value is not accessible. It is a variable defined inside the function. It is the scope of this variable is just the body of the function. So let's receive this output in a variable d, and then let's just print d, and d is 5. Great. So one more thing, let's say we define a variable here, a variable outside the function. Let's say that's a variable name. That's a very lengthy name, but let's say that's a name. Variable outside the function. Let's say its value is 3. And then let's define another function somewhere. Let's define another function down somewhere. Let's say define f maybe g, and it receives nothing, but it prints this, let's say, variable outside the function, and that's it. Let's say that's a function. Now when we call this function, this variable outside the function, that is accessible inside the function. And if this function, and if this variable, it is not defined inside here, and if this is defined somewhere else and it is global or accessible, it will still be accessible. However, if we define a function with the same name, let's say variable outside the function, let's say 5. Now this function will print 5 because that's the local variable, in the function. Now this will be accessed in this print statement. Let's see. Now the result will be 5, but if you print the variable outside, now the value will be 3, because this particular variable that was inside the function, it got destroyed when the function finishes, and this is available again. So yeah, so you need to know, by the way, it's a good practice whenever you want to access particular variable inside, it is a good practice to pass that variable as input argument to minimize the confusions, because this can create a lot of confusions. So it's a good practice, although the feature is available and sometimes useful as well, but it is always recommended to pass the values as input arguments, that whatever you want to access inside the function. Okay, so one more thing, this function g is returning nothing. For example, it is not returning anything, it is just printing, let's say, something. Let's say it is not printing anything. Let's say this is a comment. Let's say it is not printing anything. So this, and then we call this, and that's it. So it has no return value. By the way, in Python, even if a function does not return anything, it still returns a value which is called none, which you can see here. So in Python, a function always returns a value. If you write a return statement explicitly, it returns that. If you do not write return statement, when the function body finishes, it automatically returns none. Let's see the type of this output. What is the type of this output? What is the type of this none? What kind of data type is this? Let's see. It's a none type. I mean, that's a type in Python. So it returns a none type output. How fancy. Wow. One more thing, the return statement is not only used to return a particular value. If you, for example, in a particular function, let me write a function here, let's say def, let's say the function is h, and then inside that function you do something, let's say print a, let's say then you define a variable, let's say a equals 2, 3, let's say, then b equals, let's say 5, and then you add those values a and b, and then you do some other stuff, let's say print something, and then you just write a return statement without any output, or I mean it is not returning anything. You can still I mean continue writing the function body more and more, but what happens is whenever the first return will be encountered, the function returns from there. So the effective body of the function is just that. The function returns right from there. If you return a particular value, for example C, you can receive that value outside the function. If you do not return anything, just type a return statement. That means exit the function right away. It works like the break statement in loop. Remember the break statement? It resembles to the break statement. Return means just exit the function right away, no problem. And by the way, when return is called, the default return value that is returned is none type if the return is called without an argument here. So for example, let's run this function. Let's see, and let's call that function h. Yeah. So it prints a, then it prints something, and then it returns. And it returns, for example, it returns nothing but a none. It returns a none. And if you return C, for example, C, then it returns a C, value of C, which is 8. And this time, the return value is no longer none type. It is probably an integer type. Let's see. Yeah. Here. So it's integer type. Make sense? Yeah. So return statement has two purposes. One, you can return a value. Two, you can return, you can just return the control. You can just exit the function like the break and loops. Just one more thing. A return statement can return multiple values. For example, let's say we have defined a function. Let's say j. Let's say g we already have defined. We can redefine it, but let's say r is our function, and we just have a equals 5, b equals 7, and d equals, let's say something, and then we just return them a, b, and d. So return statement can return multiple values in a sequence. Now if you receive those values, let's say x, y, and z equals r, so a will be copied in, a is the first return value, it will be returned in x, it will be copied in x, b will be copied in y, and d will be copied in z, just as a sequence as you keep the sequence in the return statement. If you change the sequence in the return statement accordingly, so whatever the first value here is the first value here, whatever the second value here is the second value here, and so on. So let's run this and just print all these things x, y, and z. So yeah, 5, 7, and something. So this return statement is really powerful. I mean, it can return multiple. Not all the languages actually, they have feature to return multiple values, but Python does have feature to return more than one values, and more than one values of any type. A can have different type, B can have different type, D can have different type, and so on. So that's about the return statement, as well as the variable scope. and whether you can access a variable that is outside the function or inside the function and so on, and all that kind of things. In the next video, we'll talk about what if we want to access arbitrary number of input arguments. I mean, we do not know how many arguments will be there inside, but no matter how many arguments a particular user is giving, let's say we want to write an add function, just to give you an example. Let's say we want to write an add function. Let's say define add, let's say add2, another function add2, and let's say it receives an arbitrary number of arguments, d in, I don't know how many, and it has some implementation. Then anybody who want to call this add2, if that person gives two arguments, then just 2 should be added. If the person gives 3 arguments, then 3 should be added. I mean, the person can give arbitrary number of arguments. How can we handle that? Because the caller, this is the call. The caller can give 5 arguments, 6 arguments, 7 arguments, and earlier we saw in the definition the total number of variables. When we specify, we have to pass those many arguments for sure. If a single argument is missing or a single argument is just more than the specified number of variables, we will be getting an error. But how can we handle this situation where we have an arbitrary or variable number of input arguments? How can we handle that? So to answer this, or to get how can we do that, see our next video. It's coming. So in the last video, we were talking about how can we handle arbitrary number of input arguments. For example, let's say we want to write an add function that should be able to add any number of, let's say, integer or floating point numbers that are passed in. Remember last time we discussed in an earlier video that when you are defining a function, the total number of variables that you are defining, you have to pass exactly those many input arguments, otherwise you are getting an error. But this may be required sometime that we want to add a universal kind of add function that has capacity to receive any number of arguments, but no matter how many arguments it receives, it just add them all and return the result. Such a function, if available, will be very, very helpful, because sometimes we might be calling that function by just 2 arguments. Sometimes we might be calling that function with, let's say, 3 arguments, and sometimes more arguments or less arguments, and so on. How can we have this kind of feature available, but the implementation is just one-time implementation? Well, Python have a very, very easy way of handling this arbitrary or variable number of inputs. And the way you do that is when you are defining a function, you just write a star and then just print, let's say, one variable name, let's say args. And then after that, this args will act like a list. And I mean, it will be having a lot of properties, args. This args has a property, this acts like a list. So all the arguments that you will send in will be received like you're receiving those in one list. And all the elements, which are the arguments in the list, they are accessed by different indices. We will see lists in detail later on, but right now just think it is a collection, all the collection, it is received by indices. For example, the args, the very first element is indexed by 0. It is at the 0th location. At the 0th location, there is a 3. At the first location, for example, the location index number 1, which is actually the second look, the 4 will be copied at this, and so on. Now, no matter how many arguments you pass, a list, it will be of that size. And there is a function length, len, that is handy to just check how many arguments are there. Now, if you pass 2 arguments, the length of the args will be 2. If you have passed 3 arguments, the length of the args will be 3, and so on. No matter how many arguments you pass, this args, it will receive all them in one by one, and all the elements in that args will be indexed by 0, 1, 2, starting from 0 until the length of the args. So see, for example, here, the sum equals 0. Let's say we want to add all these. For I in range, and inside range, we just give the length of args. For this example, 1, 2, 3, 4, 5. The length of arg is 5. So I will start from 0 till till 4 because 5 is not included. So the very first time I will be 0, and args in subscript 0 is actually the value of the first variable, which is 3. So 3 is added to 0. Then next time I will be 1, and at the position 1, 4 is located. So 3 plus equals 4, which means 3 equals 3 plus 4. Sum equals whatever the sum previous value of the sum plus 4. Then next time the value of I will be 4. You know how this loop works. We discussed the loops in detail. And as you move on, you actually explore all these numbers, and this variable sum actually contains the sum of all the variables. Now you can return this sum, and this particular function acts like a universal kind of function that receives arbitrary number of arguments. How cool is that? Let's see in Jupyter Notebook to get more convinced how it works. So let's say we have define, let's say we have any function, my add, let's say that's function my add powerful, let's say, yeah, universal or universal my add universal, and it receives star whatever the variable name is. You can write the name args, or you can write any other variable name. This is just a name of a variable. Okay, then let's say we have s equals 0, which is sum. Then we just apply a loop. I guess you know the loops. We have lengthy discussion on loops. In range, length, that's a built-in function, length, args. Okay, then what should we do? S plus equals args I, which means access all the elements one by one. And this is again the same as s is equal to s plus args I. Either way you write this way or that way, both ways are fine. Then when the loop finishes, s contains the sum, just return it and you are done. Wow. Now let's call this add function my add universal, and let's call this function as 2, 4 and 5 for these, and let's just print the result. Let's just print the result. Okay, the result is 11. Wow, because 2 plus 4 plus 5 is 11. Now let's call this function for, let's say, for let's say 5 arguments. It works. It adds all these 5 numbers. Wow, that is great. I mean, now we can add any. We have one function. We need not to write a function for 2 arguments, and then another function for 3 arguments, then another function for 4 arguments, and so on. Depending upon the number of arguments, we need not to write separate functions. We have just one function working in all scenarios. Wow. So yeah, that's doable. I've done in front of you, no problem. Yeah, Python allows this. In the next video, we are going to see how can we actually handle the same kind of scenario, but we want to handle the sequence of the input variables in a very controlled way. Remember in some of the previous, in this order of input arguments, remember that we received 3 arguments and we pass the 3 arguments in a very controlled way. And then whatever these are, we don't care. Whatever the order here, we don't care. What if we want to fix the input, or we want to become more careful for input argument orderings, but then we also want the arbitrary number of arguments? How can we do that? Yeah, wait for the next video and I will show you how can you do that. In the last video, I promised you that I will show you how can you achieve the ordering of the input variables but still having the arbitrary number of them. Remember, this looks like much familiar to you. That's a call that can be made to a function, and remember the function definition in some previous slide was like C1, C2 and C3 maybe, and then something. What if we want an arbitrary number of arguments to be passed, but we want their controlled? For example, let's say this particular variable symbol name that acts as a key that's a variable name, and that's the value. So let me call the variable name as a key, and this is the value that is copied in the variable. That's another key, that's a value. That's another key, that's a value, and so on. What if we have a lot of key value pairs? What if we have a lot of them? And we also want to check which value is of what key. Let's say we want to specify those, but we want to specify an arbitrary number of them. Let's say here, for example, there are only 3. Let's say we want to pass 5 of them, 6 of them, and then we want our function to perform accordingly, no matter how many input arguments it received. Yeah, and maybe inside the function we may have applied a check that if the key value is C1, then do this processing. If the key value is C2, then do that kind of processing, and so on. Let's say based on different variable symbol names, we want to process the value differently. How can we achieve that and still having the need that these number of variables can be in a variable length? They can be an arbitrary number of those. So Python gives you, again, a very, very simple way. Rather than writing a single star, you write a double star, and then you receive in whatever variable name. And now in this double star means you are receiving a key value pair list. It's a list of key value pairs. We will see that resembles to a data structure in Python called dictionary. We will see dictionary later on in detail, but right now just consider that this input argument, this input variable C, it contains a list of key values pairs. And then you can just iterate over this C. You can just apply a for loop to check the contents of this. Remember, we have actually done that kind of thing in the portion of loops. Yeah, here. Remember, that was a key and that was a value, that was a key, that was a value, and we did that thing. We could explore we were able to explore the dictionary just using for loop. Yeah, it's the same thing here. It's not exactly, but you can think of that. That's exactly the same thing. So you can explore that C looks like a dictionary now. This is key, this is value, this is key, this is value, this is key, this is value. This X points to the first key, then C of X points to the value based on the key X, and then X points to the second key, then the second value, and so on. That is very simple procedure. You are just printing all the dictionary, but you are printing all the variable names and their values, but you can do very complicated processing if you want to. Let's go to our friend Jupyter Notebook to just get convinced that this indeed works. Let's see. So let's define a function first. So def, the function name is print all variables and values. So that might be a function name. Wow, that's lengthy one, but descriptive one. Maybe we can make it more descriptive. Print all variable names and values. Wow, that's more descriptive, I guess. So it receives, let's say, double star, any variable. Let's say the variable name is, again, let's say args or anything, whatever you want. Then what we do is for x in args, just print, let's say, variable name is, just print x, and then just print x, and then just continue, and value is args of x. So let's say you did this. So the variable name is this and the value is this. Okay, and you want to do this for all the variable and value pairs that you send at the call time. So now let's call this print all variable names and values, and let's call this, let's say the first variable name, let's say, is a, and its value is 3. The second variable name is, let's say, B. Its value is capital B. Let's say the third variable name is C. Its value is CCC. And let's say the fourth variable name, I mean, you can define an arbitrary number of arguments here. Wow, that's amazing. Let's say the fourth variable name is Y. Its value is 6.7. And further notice, you can pass a variable and value, all have different types, I mean different number of them, and much more. Yeah, you can do that. So let's call this function by just having 4 variables and their values. Let's see what we got. So variable name is A and the value is 3. Variable name is B and the value is B. Variable name is C and the value is CCC. Variable name is Y and value is 6.7. You can give an arbitrary lengthy list here if you want. And Python just allows you to do that. And it allows you to do that in a very, very simple way. That's amazing. That's amazing. I mean, that's what a high-level language, or really a powerful language, should have a feature. So Python does have this feature. I'm really amazed. I really astonish Python. By the way, I'm not saying the other languages don't have this. Several languages actually support this kind of feature, but Python supports it in a very easy way. It's very easy to do that. I mean, it's not a rocket science. Yeah. Okay, so now we have handled an arbitrary number of arguments, even with ordering is really controlled. We have 1 or 2 more videos on functions just to explain a bit more. Then we will practice on Jupyter Notebook. We will play with these functions a lot. And we will be calling one function inside the other function and so on. We will be having a better program, just program a new Jupyter Notebook just to get comfortable with these functions. But before that, let's have 1 or 2 more things to discuss about the functions. Yeah, let's see. So hope to see you in the next video. Okay, I really want to talk about these default values for a function as well, because that's important and mostly needed. The default value is a value of the input variable that you assign while you are defining a function. And if the value is, for example, if you call this f with, let's say, the input value 3, then 3 will be copied in the sum and the print will be 3. But if you call this function without the input, then this value acts as if you have passed this. So this is the default value. If you do not supply the value, this is the value that is going to operate. And by the way, you can have multiple variables with default values, some variables with default values defined, some variables with default values not defined, and so on. So you can have this. One care must be taken here that the default value, when you actually define the function and you compile this function, actually you run the cell shift enter in Jupyter Notebook, at that very time, this variable is assigned this value at that particular time. It is not assigned at the call time. So sum equals to 0 is already there when you actually press shift enter for a cell that contains this code. Now later on, if you pass a value, that value will be overwritten on sum. If you don't pass the value, the 0 will go on. It looks like very easy. But one care that I want to mention here that I haven't mentioned earlier. In Python, there are certain variables that are referenced rather than copied. I will discuss the referencing and the copying in detail in data structures, but let me just tell you one example. Let's say you defined a list, let's say 1, 2, and 3. And then what you do, you copy this list into another variable, let's say L2. What will happen is, in the memory, this list in a particular way, this is not the exact view of the memory, I'm just showing you. Let's say this is the particular memory layout for which this L is pointing to. This L is labeled for that. L2 is also labeled for that, which means actually in memory, this is not the copy of the structure that is made. I mean, this is not like in variables, for example, if A is equal to 3 and B is equal to A will be a position in memory and B will be a separate position in memory. That is what a view of the memory in ordinary variables are. But there are certain variables in memory just for memory efficient and code efficiency and time. People have designed these data structures in a way that when you copy them, when you just assign a variable to another variable, the memory view doesn't change. It's another name for the same memory location. So what happens is, if you change any value in, let's say L2, at the zeroth index, let's say you change that by -9, because it is the same view in memory that changes, -9. And now if you print the elements of L rather than L2, you will get the changed value. You will see the changed value, and that happens. Now, why that is important in terms of these default values here for the function? The reason is, if you are accepting a list, let's say the default is a list, and you're accepting a list and you are also defining some default value for the list, if that's your definition, let's say, then this default value is assigned at the very first time, and this L is really a local variable inside the memory. Now, once this cell is run, not the call time, at the what called the compile time, when the cell is run, this L is assigned this, and that just happens once. Now if you call this list with some other list, let's say L2, let's say 2, 3, and 4, then if you call this L2 will go there, it will be copied in L, and everything is fine. But don't then expect the contents of L2 to stay in L, because L is this default values, they are assigned just once, and they stay as it is every time you call the function. They don't change. They are not assigned at the call time, they are assigned at the compile time, and they stay fixed. So that care must be taken. I will show you that particular example in Jupyter Notebook shortly. This might be confusing right now because we have not seen lists in detail, but I just want to make this point. I just want to mention this because that's important difference. With ordinary variables, default value is just like a value, and if you don't supply a value, the default value just works. But with the variable that are reference type variables, you may expect something else, and the Python function behaves maybe differently, and that's because these default values, they are assigned at compile time. They are not, or compile time, actually this is not a compiled language. I should not use the word compiled again and again. Just think, when we define this function and we run the cell at that particular time, the default value is assigned, and the default value never changes. It stays fixed. Yeah. So, and I will show you that example. Why don't we move to Jupyter Notebook and see that example? Yeah. So, or why don't we do that in the next video? What do you think? This video? Okay, same video. Okay, let's go to Jupyter Notebook and see the default values. For example, let's see. Let's say we have define a function, let's say gg, and the default value s is equal to 4. Let's say that's a default value, and we want to print, let's say, s if available from the call time. If not available, then 4 will be printed. Right now we are going to print. Now we are going to press Shift Enter. At that time, s is assigned to 4. S has now value 4. It is assigned there. Now we call gg, let's say, and we call gg without input arguments. Now the 4 will be printed. If we call this gg with some input argument, let's say 56, now the 56 will be printed, no problem, everything is fine. Let's see about the lists. For example, let's say the list is, let's say 1, 2, 3, that's a list, and then L2 is simply, let's say L2 is L. Then what we do is we change the contents of L2. Let's say we change the very first value in L2 and we place that value as -9, and then we print L. Now you might be expecting that L is a different thing, L2 is a different thing, because L and L2, they both are pointing to the same memory. The content through L2 actually changes the memory view, and L also changes, and that gives the result -9 in L. Well, the behavior that I want to show you is different in the default values when we talk about. For example, let's say we define a function ff and it accepts a list, and the default value is empty list, or the default value is, let's say, 1 2. That's the default value. Let's say if no list is passed, the default list is 1 2. Now in this particular scenario, if we just print, so for example, for I in list print I, let's say we just print all the list, and that's it. Now we will press Shift Enter, and at this time this L is assigned this value, and that's a default value that is not going to change. Now let's say we have an L2 that is simply, let's say 2 3 and 4, or let's say 12 3 and 4, and what we do is we call ff and we just press Shift Enter. Now oh, why not? Oh, we call ff without anything, so the default list is printed. If we call this ff with L2, the L2 will be printed. Now notice that this L2 actually is copied in this L because we supplied it. So L and L2, you may tend to think that L is now also pointing to L2. I mean, L has also the same contents as L2. So if next time, because of the behavior of these lists, because they are by reference, next time you might be thinking that because L2 is passed there, so L2 is copied in L in a memory view layout, so L has also the same data as L2, and next time if we call this function without input arguments, then L might be pointing out to L2 value, so 12 3 and 4 might be printed. But that is not going to happen. The default values, they never change. Again, you will be getting 1 2. So the behavior of these reference type variables, that is different ordinarily, but when you do that in the default value structure, that might work in a different way. And the reason is you must know that these default values, they are assigned at the time when the function is created, not at the function when the function is called, and they are not going to change whatsoever. So that was about the default value. By the way, the default value was a simple concept. I guess I have made it too complicated by telling you lists and default values and the creation of these variables at what time and at the call time. I made this complicated, I guess. I shouldn't have told you the list values and all that stuff, but that's true. I mean, whatever I have told you is true. Maybe I have told you in a very complicated way, but it's true. Yeah. Okay. One more video on the functions, and then we will be practicing the functions in detail on Jupyter Notebook. So just bear one more video with me. Hope to see you in the next video. Okay, this is probably the last video on the functions. Yeah. Well, we will be having one more video, but that will be like coding and practicing all the concepts that we've learned about the functions, not new theoretical concepts. Yeah. So let me ask you a question to actually make you understand about this slide. Let me go to the Jupyter and ask you about a few questions. Let's say you have you have this particular function, and let's say my add universal. Let's say we have written that function maybe two or three videos before. Let's say you have this function. You have written this function and you are very, very excited. Wow, what kind of masterpiece you have generated. It can add an arbitrary number of values passed in it. Wow. But this particular function is written inside this particular file, which is mastering Python 0 to hero. Later on, let's say 2 or 3 months later, you were writing some code for some project, or you were doing something somewhere and you were writing code, and there you just needed a code for adding a lot of values together. And then you just remember, oh, I have written some function somewhere. How can I use that function? One way is to just go back to that file, mastering Python 0 to hero, and just copy this function, this code, and paste in the new file, run that, register that, and then call that happy. What if you want to use, let's say, 100 different functions? Let's say you've written a lot of functions in a lot of different files, and now you want to use all of them. And let's say this is a repetitive kind of demand. Several times you notice that this usually happens, that this particular kind of function you require almost in every project. Let's say a set of maybe 50 or 60 functions that are required always. One way to do that, as I told you, is to just copy paste those functions in every file, run them, and do that. Another way is to make a module, a file containing just those functions. And whenever any of those functions is required, just import that module into your coding file, which is one line of code, and then access all the functions as if they were actually available in the code file that you are working on. So that's about making modules of. So module is basically a Python file that contains functions that you want to use in several different coding projects, or the functions that you don't want to write in the functions having the implementation that you don't want to write in your current coding file. So you can have several of those functions stayed somewhere else in a different directory. They're residing there. Whenever you want to use any of them, you just import the whole module and use the functions. So module is just a Python file that can contain a code for you that whenever you want to use, you can use it. Normally it contains functions, maybe more than one function and several functions. Normally it contains functions that you repetitively use and that you have written once in very careful way, and then now you want to use it again and again in several different ways. You need not to write the function definition in every coding file you need. You just make one coding file, or that is the most important for you. That is called a module. Wherever you want to use any of those functions that are there in that module, you can call it, you can use it. So that's about the modules. We are going to I'm going to show you one example of making module and how to use that. But to use the module, we need to actually specify the path where the module actually resides using this sys module. So, and then we have to do this import kind of commands, and then there is some work that we need to do to actually get this module running in our code. So in the next video, I'm going to tell you what that extra work, very little amount of work, what that extra work you have to do. So here, for example, myfuncs.py, that's my Python file, and it contains these two functions. And let's say I want to use one of these or both of these functions in some other file, and that file contains this particular code. So in the next video, I will show you how to actually make and use the modules. Yeah, so hope to see you in the next video. Okay, in the last video I told you about modules. Module is just a Python file that can contain a code that can be used anywhere if you want. Normally the modules, they contain a lot of functions, but they can contain variables and other values and so on. So think about file myfuncs.py that contain these two functions, and think about a different file, maybe Jupyter, maybe you're working in a Jupyter notebook and now you want to use these two functions. So you first have to import another module called the system module sys, you have to make this path available. There are a lot of built-in modules that are already there in the path, already there in the search path. When you want to call a function, it is written in some module that is already in the search path. If you are making your modules, you have to either copy those modules into the modules that are built in, or if you want to maintain them separately somewhere else, then you have to add the path of these in the search path as well. And the way to actually insert this path is sys.path.append, and then you actually write the path of the directory where this module file, one or more files, are located. Once this is added to the path, now you can write the import, and you can import your file and your file as it is, or you can import your file with some other name if you want. You can rename that on the fly if you want. Once this is imported, now you can use all the functions like the built-in functions. The implementation of these functions are not there in your coding file. You are just using those, and you can now import these module into some other file and use there, and so on. For very large kind of projects, it is good to make modules. Actually, it is better to make packages, which is actually the directory structures that contain modules. But modules at least are really good to for maintaining a large amount of codes, or actually the functions that you want to use again and again. So let's let's make a module. Why not? So let's make a module. Let's go to Jupyter Notebook. Let's create another file. Let's say new Python 3, and let's name this file as let's name this file as my universal. Let's use underscores, my universal functions. Let's say that's the file name. Let's create another notebook. Right now it's just a notebook. Let's define some functions. Let's say we want to define one function as check all args. Let's say that's the function. It receives, let's say it receives a dictionary like input, and then it checks the type. Let's say check type of all args, and let's say you write a function check if not numeric. Let's say you want to write a function that just accepts a lot of arguments, and you want to check whether any one of them, if any one of them is not numeric, you want to return, let's say, a flag. Otherwise you want to return a true, let's say. So for example, you may need this function in several places. Let's say in your code you're expecting numerical inputs, and if the input is, and let's say there are a lot of variables that you are working on, if any one of them is not numeric, you might want to check all the variables and their values. So one way of doing that is just to create a list, and that's it. I mean, that's and you may have several of those. I mean, you can check all of them. Maybe here we do not need the dictionary kind of argument, so maybe we just are happy with just one. So let's say so the output, let's say output is, let's say, or the return value, ret value, let's say that is already true, and we will say okay, for x in args, let's say for x in args, if x is instance, x is int float. If that is true, then we are happy. But if that is not true, then there is a trouble. Then we say, okay, if this is not true for any value, then we just return false. Okay, we just return false. I mean, we need not to break anything. We just return false. Return means return, whatever. Otherwise, if we finish this loop, if the loop finishes successfully, there is no return statement that is called already, then we return maybe true. So we do not need actually this variable. That's it. So this function will return true if all the variables are either int or float. If any of them is not of this type, this function returns false. Wow. We can have another function maybe. We can write several functions in the same cell or in different cells, either way. Define, let's say, another function, universal, or add all values. Let's say add all, let's say numerics, add all numerics. And it also contains, let's say, args, and the goal of this function is just to add all the values and return the sum. So let's say s equals 0 for x in args, s plus equals to x, and that's it. Then return s. Let's say these are two functions, and maybe one more, the name of this, or some variable. Let's say I mean, these are two functions. Now we are out of the function. We are writing something else. Let's say my name. Let's say that's a variable. My name. This my name variable does not belong to any of these functions, and my name is Python course. Let's say that's my name. So that's it. That's a file with the name my universal functions. So what we do is we download this file as a .py file. So what we do really is we go to file. Let me just zoom this out so that you can see the download options. We go to file menu. We download this as py file. So Python file. So let's download this. Or we can write this Python file as in some other editor if we want. So open folder, there is a Python file here, copy it. Now copy that file, and now you're free to go to any, for example, any folder if you want. Just for example, you go to somewhere in your directory and make a new directory. Maybe you want to make another directory. For example, go and make a directory maybe in D, let's say, or maybe in E, let's say, or maybe in C, somewhere. I mean, make a module anywhere. For example, in C, make a new folder, call that folder as my, or any name, whatever name you want. For example, my module, or let's say, utils, for example, utilities, or whatever name. I mean, let's call it as ABC, for example, ABC, whatever. And you just make that and just copy that Python file here, my universal functions.py. Now if you go back to your where is the Jupyter? Here is the Jupyter. Now you go back to your code. This is your file. Go back to your code. Let's say this file is no longer here, and what you do is you import sys, that's a system module, then sys.path.append. Write the path here where the module is located. So the module right now is located at ABC. This is the path of the module. Once done, you can import. What was the name of the module? You need to know that. That was my what? So I just don't remember the name. Let's import my universal functions. How it appears. Actually, when I have added this path, then this import command, and after the tab completion, just fetches that file. So that name might be very lengthy, so you can rename that as, let's say, my fs, or whatever name you want. So you import that. Once you have imported that, now you can use the functions if you want. For example, you can check the implementation of my fs dot. If you see dot add numerics, you want to check the implementation of that here. Remember, this file is no longer in this particular file. This is located somewhere else, and you can call this function like the built-in functions, my fs dot add all numerics, and you can have, for example, let's say it accepts the input arguments, let's say 2, 3, 4, well, let's say 6, and that's it. That's the return value. You can save the return value in some other variable, let's say C, and then later on you can print this C, or do some stuff with this C. That's one thing. Another way of importing the same thing is, let's say you don't want to use all the functions, you just need this add all numerics. Let's say that's the only function that you want to use again and again. So you need not the other functions. Let's say for this particular file you do not need the other functions. Then what you can do is you can just say, okay, from my universal functions import add all numerics, and you can rename this function as something, and you can call that function the same way. So you do that. Now you need not to write any dot kind of thing. You just call add all numerics because it is imported now, and you say, okay, 2, 3, 4, 5, 6, 7, and you save that in, let's say, D, and then you print D if you want, or do whatever with that. That's it. Or you can import multiple functions, or you can import all of them. Other than modules, there are, for complex codes, this is not one module that is there. There are several modules, and the several modules may be arranged in a directory structure where the directory and the subdirectory and the subdirectory and so on. So the modules that are arranged in directory structure, although they are accessed much like the same way, that directory structure is sometimes called package. And these are basically the packages that are most useful, and we will be seeing some data science packages, like NumPy is a data science package. Then we will be seeing Pandas, that's a data science package. We will be seeing Matplotlib, that's a data science package for plotting and visualizations and stuff. So package is just the modules that are arranged in directory structures. So now you know what module is, and we actually missed to import the name. To see the name, we have saved a name there as well. So let's go back and do that and see how many things are available. Let's go to some other cell, an empty cell. So my fs dot tab completion, my name is available. Remember that was a variable? Yeah, that's available. So the name is Python course. So this module file does not require to only contain functions. It can contain any information, any data that you want to use in other files, other coding and stuff and so on. So yeah, that's about modules. In the next video, we will practice about these functions a little bit. We will be seeing how to call a function inside another function, how to make a lot of functions that are calling each other and so on. So we will be practicing more about these functions, not theoretically, just on Jupyter Notebook, just to get a better look and feel of functions more. And after that practice, we will be then jumping towards data structures starting from strings. So hope to see you in the next video. Okay, before moving on, let's just practice some I mean, let's get a good grip on functions and multiple functions and handling those. And the best way to do that is to solve actually a problem. Remember, we solved a problem when we were done with if conditions. Then we solved another problem when we were done with loops, just to get a good grip on loops. Let's solve a problem. Let's just solve a problem using the functions, just to get a good idea of functions. What kind of problem should we solve here? Should we solve an older problem? Last time we solved a problem using loops that were sorting a list. Why don't we solve the same problem but in a different way? So let's go to Jupyter and see our file, Jupyter file. We have actually solved a function somewhere using loops. Just let me just find that out. Oh yeah, they're here. So given a list of numbers, let's this, make another list, or maybe the same list, that contains all the items in the sorted order from minimum to maximum. Your result will be another list like this. And we solve that using loops. Okay, let's solve the same problem. Exactly the same problems. Let's solve the same problem using a different way, using functions, just to get a grip on functions. So let's say that's our problem we want to solve. So that's the problem again, and we want to solve that. So how can we solve that? To solve that, let's first define a function. Let's just make a function. Let's just make a function that let's say define find minimum, and the function accepts a list and returns the minimum value in the list. Not only the minimum value of the list, but also the position of that minimum value. So find minimum as well as find minimum as well as the position of the minimum in the list. So how can we solve that problem? That's one standalone function. No matter what list you pass in, it will find the minimum. Okay, as long as the minimum is defined for the items of the list. For example, the list items are, let's say, all numerics. Okay, how can we do that? Let's say minimum value is the list 0. That's, let's say, the minimum value. And right now the index at the minimum value is, let's say, is 0. Okay, like we did in the loops. Like it is kind of the same code, but let's write a function for it. Okay, so that's a function, find min. So how can we proceed? What should we write here? Let's see a counter. Let's say counter is, let's say, or I maybe. Let's say the counter right now is 0 for x in L if x is smaller than our minimum value. If that's true, then the minimum value indeed is x, and the index where we found that is I. Okay, great. Else do nothing. I mean, else just go away. And I plus equals 1. So move on. So I is just the position. So I is moving on and on and on as you follow the list. And m contains the minimum value, and idx variable contains the position of the minimum value. So that's the function. For readability, we might be adding an else clause just to write pass, and that means the if condition finishes. I mean, if this condition holds true, do that stuff, otherwise do nothing. That's just because of readability. If you want, even if you don't write the else clause in pass statement, even then everything is fine. So let's call this function just to test whether this function is working properly or not. So let's just find, oh, we haven't returned anything. We need the minimum value as well as the index. So return minimum value as well as the position. So return that. Okay. Oh, but we are returning that inside the loop. That becomes in the body of the loop. Oh, no. That's bad, because even in the first iteration, the return will be called, and even in the first iteration, the function will finish. Indentation, remember indentation? Now that's better. Now this is no longer inside the body of the loop. Great, that was a bug. We fixed it. Great. Okay. So let's call find, let's receive a, b. So a will contain the minimum value and b will contain the index of the minimum value. So find min, for example, and the list, let's give it the list 1 3 4 2 3 4 0 9, let's say. Now the minimum value is 0 and that minimum value appears at 0 1 2 3. That's the third index. So b should be 3, a should be 0. So let's see what's the value, what's the result. So print ab. So a is 0, yes, and the position of minimum is 3. I guess it is working fine. Great. So that's one function, find minimum. Let's find another. Let's write another function, swap. So define another function. Let's say swap values, and what we do is it actually accepts two indices, index 1. It actually accepts a list, then two indices, index 1 and index 2. And what it does is it actually swaps the value of index. So index 1 value should go to index 2 position and index 2 value should go to index 1 position in the same list, and then it returns the list. Okay, great. So so that's a good example. It accepts a list type variable, it accepts index type variable, which are integers. Great. So let's define a variable temp that contains L idx index 1. Just store it in a temporary variable. Then at this particular index 1, just copy this value. Don't worry, we will see lists in detail later on. Now now at index 1, the value of index 2 is copied, but it is not overwritten because we already have saved the value somewhere before that copying appears. So L at idx2 is simply temp, and now return the list. So that's how you can swap the two values if you want. Great. So let's just check it whether the two values are swapped or not. So let's say list is 2 3 6 and 7. Let's say that's list, and let's say we want L2, that is swap values, and let's say we pass the list and we want the values to be swapped at position 1 and position 3, which means at position 1 the value is 3 because the position starts from 0, and at the third position the value is 7. So we want these to swap. So the result will be 2 7 6 and 3. Let's see what's the result. So let's print L2, and yeah, it works. Great. What else do we need? So we have find minimum function, we have swap values function. What else? So yeah, what should we do? Now let's write the main function, sorting. Let's write that function, and we will use these kind of functions inside that function. We will call these functions. So let's define sort list. Let's say that's our function. It accepts a list and it returns a sorted list. Okay, what should we do? What do you think? What should we do for the very first time? Well, first of all, we should check whether all these list it contains the list contains all the numeric values or not. Let's say we are just doing this for numeric values. So we should first check that all the arguments are of numeric type or not. For that, we should write a function that should do that. Oh, remember that function is all written in a module. Remember that module? We made that module ourselves. So we can import that module if we want. Import remember that my universal functions, and we just need that function. We just need that function. Just from my universal functions import what? Import check if numerics, check if not numeric as, so you can write that function name something else, but just this. So you import that function. Now you may be able to use that function. So after that, you can use that function. If check if not numeric list. Remember that function returns true if all the values are numeric, otherwise it returns false. So if it is true, then move on. If it is not true, what should you do if it is not true? If it is not true, then you might be printing an error. List does not contain numeric values, maybe that, and then you just return. That's it. I mean, return. Don't need to write anything in return. Fine, great. So else, we need not to write else because this return will take care of that, but it is for readability, it is good to write else. If all are numeric, then what should we do? Okay, what should we do if all are numeric? What we do is we will be doing what? We will be finding minimum. We'll be finding out the minimum, and then we will be swapping the minimum from what should we do? We have already a function find minimum that we can call just right away. We have a function swap values that we can call right away. We already have used this function. How can we combine all these functions? How can we use all these functions just to achieve the problem sorting? We want to sort a list. How can we do that? Okay, yeah, that's it looks like yeah, it looks like a different thing. Maybe so let's just write out. Let's just for x in the list. Let's start thinking here for every element that is in list. For x in list, what should we do? We should find out the minimum and swap the minimum with x. So we should find out the minimum as well as the index of the minimum, and should swap it with the value x, and everything will become great. Yeah, I guess yes. Okay, so what we are going to do is we are going to maintain a counter. Right now the counter is 0, which is just the index. What we are going to do is we are going to find out the minimum and the index where the minimum lies. So by find minimum in the list, so it will return us the minimum as well as the index where the minimum lies. And then what we do is we will say okay, okay, what we want to do is L is actually L is swap values with index C, swap values in the list with index C. So index C should be swapped with IDX. Yeah, and C plus equals 1. Will that work? Will that work? So after this, will the whole list be sorted? So let's return list L. Is that true? I mean, we are finding out the minimum value one by one. The only catch is the list is updated here, and oh, there is a problem. When we are finding out the minimum, we are finding out the minimum from the list, and every time the same minimum will be returned. That's a big problem. So looks like this find minimum function is not doing our job. what we need to do really is we should go to find minimum function and give it that start your find minimum from a particular index. So don't search the whole list to find the minimum. Start finding out the minimum from the following index, for example. So let's give a start index and maybe an end index, but let's give a start index. So start searching the minimum from right from there. How can we change all the code right now? Oh, that's a bad thing. Let's change the code. Let's say that's the start index. Start index. Let's say this. The index right now is start index, and I is also start. We may use a range function here. That might be much more feasible to us. So let's use a range function rather than this. Let's change the coding a whole lot. That's a bad thing. We need to change the code. For I in range, starting from start index, starting from start index, ending at length of the list, and doing a step of 1. Okay, now x is really list at the index I. Okay, if x is smaller than m, then this is that, and index is I. Otherwise this, we need not to do this because this is happening automatically, and rest of the story is same. I guess yes, that will work out. Okay, great. Oh, there is a problem. Oh, we just missed this colon here. Great, we fix it. Okay, now swap value is there. Maybe this works, maybe it doesn't. Maybe there is a bug. Let's see. Let's just call this function. So let's call this function L2 is sort list, and let's pass the list as 2 1 5 3 -8 17. Let's pass this list and see what it returns. If it returns fine, we might be happy. Otherwise we will see where is the bug, if there is a bug. Oh, list does not contain numeric values. Why not? List does not contain numeric values? Why is that happening? List actually contains all the numeric values. Where is the problem? Check if not numeric. Let's see the implementation of check if not numeric. Let's see that. Check if not numeric. Let's see the implementation. And where is the bug? Because all these are numeric. So check if not numeric, x in args. If not is instance, then return false. So if everything is int or float, so if x is int or float, then otherwise return true. So it returns true if all are numerics. So it returns true if all are numerics. So not true means false, and why it is returning false. So let us just see why it is returning false. That's a bad news. Something is happening wrong. Let us just see how this is working. So let us just check if not numeric, and let's pass the list, this list, and let's see what is returned. Let's just print the return thing. Print. It is either true or false. So it returns a false. Why it is returning a false? It is a bad thing. Why it is returning a false? Let's go to the file. Let's go to the file. Here. Let's go to the file here in this directory. let's open up this. Maybe we open this in simply a notepad, maybe a notepad, why not, or maybe some other fancy editor. Let's open this up and see what is happening. Edit, format, font. Let's have a bigger font and see what is happening. Let's have font of 20. Yeah, bugs are bad. They're really bad. For X in args, okay, if not is instance, so first of all, is instance this, it will return true always, okay. If not true, which means false, then we'll move on and the loop will be running. If anywhere where it is finding out basically. So this is working really fine. Let's write this function somewhere inside our notebook and see what is, let's say, rather than this, let's write this function like check numeric 2, check numeric 2, check if not numeric 2, and let's call that function and see what happens. Check numeric 2. It is returning false again. Why it is returning false? That's amazing. Where is the false? So 2 is integer, yes. 1 is integer, yes. So true, 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 true. All these are true. Oh, -8 might be a problem. -8 might be a problem. Let's see. Maybe, I don't know. Well, it is still false. I mean, I'm stuck here. Guys, I'm stuck here. I don't know what to do. I have to debug this function. I have to go inside that function and see what is happening. So what we really, args, oh my god, the big trouble. Yeah, I found the error. We are passing a list, and that list is just one argument. That is not a lot of arguments. We have to pass all these arguments in a different way. I mean, if you want to, you're getting the bug. The bug is we are passing one variable, not a lot of them. 2, 1, 5, 3, 8, 17. These are not all different variables. For example, if we just go inside and print x for just first x, it is all the list. It is all the list. It is not the variables one by one. Let's see. Yeah, I found the bug. Great. Yeah, see, it is not a lot of variables. It is not a lot of arguments. It is just one argument that is in the form of list variable. That's the trouble. What should we do? Should we go inside and add another function, check if not numeric for lists rather than variable number of arguments? What should we do? Let's write another function that check for the list. Let's write here check numeric 2. It contains a list, for example. Just accepts list L, or maybe L or whatever, X, or just simply you can call or L list, and it goes through all the list and does the same job as previous. So now this will work. So the function that was there in our module is no longer working, and it will not work. Yeah. So we are not going to use the function that is in the module. We are going to write another function that will help us here, and we have written that, and here we go. We just chain that function with that, and we just register that again, and let's see what happens now. Oh, there is another error. Which error? Find min missing one. Oh, we did not find this. Find min is missing the starting index. So the starting index is C. Great. That's a problem. That's a huge problem. List is sorted. Oh my god, list finally is sorted. Oh, huge. So you see, you can call the functions inside other functions. You can call the functions from modules. If they are no longer working or no longer beneficial for you, you can write new functions. You can call them. You can, yeah, all that stuff. I guess that lengthy video taught you a lot of lessons, how to code actually. And this actually happens when you are doing tasks that are really big. You have to define different functions. You need to define different functions for modular approach and focus on each function as a separate entity, and that makes much simplicity in managing the code and bug fixing and all that stuff. You see, I fixed the bug by just noticing that, by just focusing on this function. I have not thought anything else. Just focus on that function, go and see the implementation, fix that, everything else stays the same. Yeah, so too lengthy, I stop here. Okay, now you have done a lot of practice about functions, loops, and a lot of stuff. That was all the basic programming in Python. In the next video, from the next video, we will see the real power, a much more real power of Python, where you need not write a lot of loops and a lot of code, and still you will be able to achieve a lot of stuff. And for that, we need to go through the data structures that are available in Python. So from the very next video, we will start seeing strings. That's the data structure. We will see list in detail. We will see set in detail. We will see dictionary in detail. We will see tuples in detail. And after going through all these data structures and getting a good grip for the data structures, then finally we will move to the packages that are available for data science, particularly NumPy, Pandas, Matplotlib. And we will see, maybe I include 1 or 2 videos for scikit-learn as well. So hope to see you for the whole new phase in Python, the data structures. So hope to see you in the next video. Okay, let's dive into the long-awaited strings. String is basically just a sequence of characters, and it's a data type. It's kind of a data type in Python. It's much more powerful. The reason of making this a whole new data type in almost every language is, the reason is that almost all the data, all the text that appears in sequence of characters, so making that sequence of character the whole text as one kind of data type, and writing special kind of functions to deal with that text might be necessary. And that's what string is. In Python, for example, you can declare a string variable, s, or any variable name, by just double quotes, let's say A, B, C, or equivalently by single quotes. Either way is fine, D, E, F. So either way is fine. You can declare using double quotes or single quotes. Either way is fine. One thing is, be careful, don't mix, don't start by single quote and think that now I will end with double quote and that will be fine. So don't mix them together. If you're using single quotes, use single quotes. If you're using double quotes, use double quotes. Don't mix them together. That might be much more confusing later on. So let's say this S is a string. Python is the best language for data science. Let's say T is another string that is defined by single quotes. In this course, we are going to learn Python. Then you can print S in a different way. Let's say you can call a print S. You can call a print to T. Or you can just, by the way, you can add 2 string variables, S and T, and the result is a new variable. That's a V. How the plus symbol works in strings is, plus in strings means just concatenate them together. So first you just copy this string, the whole string, and then you just concatenate the other string with it, and the result is a new string. Now that's a new variable. You can use that variable and do a lot of stuff with it. So let's go to Python and see actually the prints in the strings in the running form. So let's say S is string. Let's say Python is a good language. Let's say and let's have another string t that is using single quotes. It's good for data science, SCINC. Okay, it's good for data science. Let's run these two and see the type of S. What's the type of S? The type is str, string, str. That's what the type is. And if you just print S, that will be printed. Python is a good language. Remember, so far we are using this print, and always we use this kind of hello or something like that. That basically is a string because, by the way, this print function actually it takes an arbitrary number of arguments. We can print hello, then we can print anything in another type, then we can print another hello, let's say hello 2, hello 2. That's a multi-variable argument function print. Then we can have another string, maybe who are you, and then maybe a floating point number 5.9. So we have used these kind of I mean stuff a lot. We have used print function, and we were using these double quotes again and again, but these are actually strings that we were using later there. So this print function actually accepts strings and all these kind of. Normally, whenever you use print, normally you're going to actually display some text, and maybe you're writing that text into some file and so on. So this string is highly useful. Most of the data is available in the text form, in the string form, and we want to process the data, we want to find the anomalies in data, we want to fix them. Again, we want to stay in the text. So it is good to have a data type that actually have a lot of functionality that handles all that stuff. So let's see, for example, let's see how can we concatenate the two strings. For example, S and T. Let's say we have V, that is S plus T. That's concatenated V, and let's print V, and V is concatenated. Wow, Python is a good language. It's good for data science. Well, it is concatenated, but there is no space between two, because wherever the first string ends, the second string starts right from there. What if we concatenate three strings? S plus another string that just contains a space character, then this string. By the way, whatever that is there in double quotes or single quotes, whatever, one character, two character, all these things are called strings. So now we are concatenating three strings together: S, a space, one space string that contains just a space character, then T. And let's see what happens now. So Python is a good language, space, it's good for data science and so on. Wow. So yeah, so that's basically the introduction of string. What if we want, for example, to concatenate, what if we have a variable A, which is 12, and let's say we have a variable B, which is the price of this book. Let's say the price of this book, and A is 12. So let's say this is our price. Now price is in integer form, S is in book form. Let's say we want to make another string V that contains the following kind of thing: the price of this book is, and then whatever the price is, that should be there. So how can we do that? So let's say S plus maybe another string is, then maybe a space, so that after that the price appears. Now if we write plus and write price, price is no longer a string, it is an integer, and an integer cannot be concatenated with the string in a straightforward way like plus. How can we make a message like the price of this book is whatever the value of the price is? One way to do that is to convert the variable price, convert the type of the variable of price from integer to string. That means whatever the value, in this case 12, is written, that becomes a string of characters 1 and 2, and now it can be concatenated with the rest of the string, and we will contain the message that we want. So for example, if we now see what is V, that is the price of this book is 12. Oh, we don't have a space before is, so let's type a space there. Space is also a character, can be handled in string. Wow. So that's how we can convert different types to string. We can have a float type, we can convert that to string, and so on. Another way of doing the same or achieving the same kind of stuff is to write print the price of this book is, we can use the power of the variable number of arguments of then price. That's exactly the same thing. The price of this book is 12, the price of this book. However, consider one thing, the print function automatically adds the space for different kind of arguments. You can see that here. Yeah, you need not to specify a space. The space is automatically added if it is considered to be a different argument in the print function. Okay, great. So that's the introduction of a string. We are going to explore string in a much more detail in the upcoming videos. So stay with us. We are going to see string in much more detail. Okay, hope to see you in the next video. A string might be very lengthy or may span, very lengthy and may span more than one lines. Or maybe the formatting is in a way that you want to, even if it is not very lengthy, you still want the different chunks of the same string to be appear in different lines. So there is a way to declare multi-line string, again using either 3 single quotes or 3 double quotes, and then 3 double quotes or single quotes, whatever convention you follow. And then you write all the string in no matter how many lines you want, and that one variable actually contains a multi-line string. If you now print, for example, if you call the print function on this multi-line, that's by the way a variable name, multi-line string that contains this data. Multi-line, multi-line, that the spellings are wrong here. I just written multi-line. Anyways, if you call that print function, the print will display this string as it is, like it is there. So let's see and by the way, the same multi-line string kind of fashion, remember that is used for comments as well. If you have comments that span on multiple lines, you can use this. So this multi-line string really is, if it is not saved in a variable and used as it is somewhere in the code, then that acts as a multi-line comment. Great. So let's practice the multi-line string in Jupyter Notebook. Let's see. So let's say we have a variable a that is a multi-line string, and let's say the string is, this is line 1, then we have this is line 2, and then we have this is last line, and this line is 3. That's it. Okay, great. That's a multi-line string. Let's see if we print a, what happens. So this is line 1, this is line 2, this is last line, and this line is 3. Why this is shifted one character right? Oh, there is a space here. Let's remove that space if not required and run this again. Wow, because space is a character that will be printed if you want. Okay, what if you really want the following kind of stuff? You have, let's say, print. So what you really do is you want to print the following way. The following options are available. And the options are, let's say, tab, let's say hyphen a, and that does -a that does nothing, and then we have, let's say, -b, and that also does nothing. Let's say you want our message to be printed in such a way. What will happen? Let's see. Okay, the following options are available. -a does nothing, -b. I mean, all this is a string, multi-line string. These characters that you think they are not there, these are spaces, and they are, I mean, the spaces are printed here. The spaces are printed here where you're seeing nothing is printed. These are the spaces that are printed there. So sometimes this multi-line string, it helps to format our message in a way that we like. So that's helpful in most of the cases. Further, if you write this multi-line, by the way, if you write this multi-line comment in the start and end of any code script, that means if you write this multi-line way of defining the strings at the start and end of any code script, that code script is commented. That we have seen several times earlier as well. So for example, in problem solving, remember that we define all, oh yeah, so that's the comment. That's a comment. Even if some code is written inside, that will not be executed, right? Okay, so that's about the multi-line string. In the next video, we will see, because the string really is basically a collection of all these characters. What if we want to access a particular character? For example, this is the first character is T here, the second character is H, the third character is I, the fourth character is S, the fifth character is space, and all that. What if we want to access particular characters inside the string? Because a string contains a lot of characters. What if we want to play with some of the characters inside the string? How can we access different characters? For example, if I want to access a seventh character of the string, how can we do that? So let's see in the next video, how can we index different characters inside a string. Hope to see you in the next video. Okay, in this video, we are going to actually access different characters inside the string, sometimes called indexing. The term slicing is basically more relevant to arrays, lists, or actually the mutable structures, but we will see. I'm just comparing, because you may listen this term slicing again and again, but really it is indexing. But we will see the indexing or slicing sometimes is used. These two terms are used interchangeably. We will see the examples of slicing in detail in lists and in more detail in NumPy arrays. But here you just think that indexing and slicing are the same things. Index. So for example, I have this A, let's say this is A, array A, and I want to access its fourth element. Here the fourth character element is E. By the way, this A is a variable. If I want to access the very first character, the indexing, the number, the positioning starts from the integer 0. That's the first character. So if I want to print out of it, that will print G. If I access, for example, if I write the index 3, what do we mean? That means the fourth element. The fourth element is E. What will be printed? What will be printed if I access the fourth element, or the index 4? If I access this thing, a space will be printed, and you will be seeing nothing, because when a space is printed, actually nothing colorful is printed there, and you might be thinking, oh, nothing is printed, nothing have been accessed. Actually, a space character have been accessed. So yeah, we can actually access a substring inside a string as well. For example, we want to access, for example, a substring starting from index 3 and all the way up to index 8, but does not include the index 8. So it will include the character at index 3, which is E, character at index 4, which is space. Let me write space in this way. Character at index 5, which is O, character at index 6, next character, which is F, then a space, which is 7, and then the character at 8. So this is not included to be accessed. This is included. This is inside. This is included. This is not included. So we can access a substring. So starting from 3, ending at 8. Let's see an example, and we'll come back to this slide again after a few minutes. So let's say we have a string S. Let's say, how are you? And who are you? Let's say. So let's say that's a string. Okay. And what we really want is we want to access, for example, we want to access the element. To access the elements, you have to write the square brackets. That's a standard notation in Python. Whenever you have a collection and you want to access different elements, that collection might be a string. That collection later on we will see might be a list, maybe a tuple, dictionary, maybe a set, maybe an NumPy array, maybe a Pandas structure. I mean anything that is a collection. Normally it is accessed by, if it has different elements and we want to index them, the indexing notation is square brackets. And indexing always starts from 0 rather than 1 in Python. There are some languages in which the indexing starts from 1. For example, Matplotlib, the indexing starts from 1, but in Python and in several other languages, the indexing starts from 0, which has some benefits over starting with 1. It has some benefits, so starting with 0 is okay. So let's say we want to access element at index 5. The element at index 5 is actually the 6th element in the string starting from 0. So first, second, third, fourth, fifth, 6th. So R will be printed. So let's see. R is printed. Let's check the type of this return value. Let's check the type of this this one element, which is R. What is the type of it? So type of different elements in a string, different characters in a string. What are the types? So what is the type of it? So the type is also string. So each and every character is also of string type. In some other languages, the type might be a character. Character is another type, but in Python, each and every one character is also a string. More than one characters is also string, as long as they are accessed from a string. Okay, let's access, for example, the element number 3 to element number, let's say, 8. So the result is R. So element number 3, not 3, actually starting from index 3, which means the 4th character, which is space, and then RE, and then space, and then we finish. If we, for example, move from 3 to 9, let's say, and the value will be RY, or we may move to, for example, we may start from the very beginning. So for example, index 0. We may end at the index 10, but not including the 10. So the result is how are U and I mean YO and not the U included, because that's the index number 10 and index number 10, the last index is not included. Great. We can have negative indices in strings as well. So a negative index is just the indexing from the right side, not from the left side. For example, a negative index, so -1 points to the last character, for example, U. Similarly, -2 points to the second last character, and so on. So -1, let's say it will access U. And similarly, we have -3, and that will access Y. Or we may have start from, let's say, -8 and go till -3. That means go back to -8 index and then move to -3 index. Okay, and -3 in this case, let's see what's the result. R. Why is that? Why R? Oh, this R. I guess this R. Let's check it out. So this is -1, -2, -3. That's index number 3. So 3 is not included. -3 is not included, so it has to stop here. Okay. That's -4, -5, -6, -7, and -8. Oh, great. So that should be printed. It has printed. So let's say we have, rather than -8, we start from -12 and we reach to -3. So whoa. Okay, great. So we have negative indices as well. And by the way, this kind of fetching this kind of substring is sometimes called slicing. I mean, we are just fetching the slicing. Although the term slicing is much more popular in mutable data structures. What is a mutable data structure? What is an immutable data structure? Well, yeah, I should tell you right now. You cannot change any character in the string. That might look like a bad news for you, but once the string is created, the elements in the strings are not changeable. So for example, let's say at position number 1, you want to place a character, let's say E. That's not possible, and the reason is the string is a data structure. The string is a variable type, a data type that is immutable or unchangeable. Once created, you cannot change its contents. They stay fixed. You cannot change them, you cannot alter them, you cannot delete certain contents from it. I mean, once created, it stays as it is. You can copy this into another string. You can copy and paste, but you can get a substring and copy into another variable, for example. But the contents of S cannot be changed. So all the kind of data types in Python that are unchangeable, the contents are not changeable, they are called immutable, and string is immutable. So the term slicing makes much more sense, or it is more popular in the data structures that are mutable. Although you can use the term slicing, indexing both interchangeably, but it refers to fetching a substructure or substring. In this case, in the list, it will be a sublist or so on. So that's what slicing is. Yeah, great. Why don't we do some more fun with this string? Yeah, let me show you more fun with this string. More indexing. Let's say you start at index 0, you go to index 12, but not including 12, and then you take a jump of 2 rather than 1. What will it do is, it will fetch all the characters starting from index 0 all the way to index 12, but not including 12. But it will take a jump of 2 rather than taking a jump of 2. So first character, then take a jump of 2, then pick a character, then take a jump of 2, and then pick a character. So it will actually pick every other character starting from 0. So let's see that. So for example, if you remember the string, that's the string. So it starts from H, fine. Then it skips O and go to W. Then it skips space and go to A. Then it skips R and go to E. Then it skips space and go to U. And then it skips O and go to U. And then the 12th achieved, and we stop there. Wow. So the general way of slicing or indexing, the general way is you have a start index, start, then you have end index, and then you have step size. If you do not mention the step size by default is 1, that we were doing already. If you do not mention the end, the default end is till the end, the total list size. If you do not mention the start, the default start is 0. For example, let me make that a comment and just practice a few. For example, let's start from 0. We do not mention the start. Let's start from 0 and go to 12. If we do not mention the starting index, that starts from the very beginning, 0. Go till 12. Okay, great. If we do not mention, for example, we start from 3 and we do not mention the end, that means go till the end, starting from index 3, including the last character. Okay. If we do not mention the step, for example, if you start from 1, go till 12, and we do not mention the step, the default step is 1. Okay. There is one way of reversing the string. I mean, very beautiful way. I mean, you do not start the mention. You do not mention the start. You do not mention the end, and then just take a step of -1. In this particular way, the start and end index, they are just swapped, and you get the string reversed way. Wow! So that's the reverse string. Isn't that fancy? Yes, it is. Okay. A lot about indexing. You can find out the length of any string by using len function. You can find out the length of any substring if you want to, if you have a substring, using again a length function, len. That's okay. Okay, now we have seen how to access substrings and how we cannot change the elements of a string because it is immutable, but we can access them. We can just display them. We can analyze them and so on. In the next video, we will see some functions that are supplied for string processing. What we can do with strings, and I mean, how can we manipulate those strings? Although we cannot manipulate the contents of a string, but we may copy a string, we may get a string, manipulate it, and save it to another variable, and what kind of functions that are available in string data structure, string data type. So let's see that in the next video. Hope to see you in the next video. Okay, let's see different functions that are available to play with the strings in this string data structure. Let's say you have this string a lot of spaces. These are a lot of spaces at the beginning, and these are a lot of spaces at the end. There are some spaces in the middle as well. So there is one function called strip. All the functions of the string, they are called by taking a dot something. These are called methods. You can loosely call them functions, but those kind of functions that are related to some data structure and called with dot, they are sometimes called methods. The term method is more related to object-oriented programming. Actually, string is a class, so all these are the methods. But even without knowing that, it's perfectly okay. You can call it method or function. That's perfectly okay. You can, I mean, it's okay. It's okay without knowing what a class is, without knowing what an object-oriented programming is. This a dot some function that operates on this a. One difference with method and function is when you call a function with a dot and you call some function, let's say a dot strip, then inside the definition of the function, this a object or the a variable is available, like you have passed that variable as an input argument. That's all you need to know about the difference of method and function. The rest of the story is perfectly okay even if you don't know. That's fine. Okay, a dot strip. It operates on a, which means the a is passed in this function as just as input argument, or it is available there inside the function implementation. And then the strip function, what it does is it removes all the spaces that are in the beginning and removes all the spaces that are at the end, and returns another string that has no spaces at the beginning and no spaces at the end. And the new string is copied or created in a variable b, let's say, whatever that variable, we can have another name of that variable. So let's see the running form of this strip function in our friend Jupyter Notebook. So let's say a is a string variable. Let's say a lot of spaces, a, b, c, d, e, f, a lot of spaces, then h, g, q, and whatever, and then a lot of spaces. Let's say this is a, and then we have b. Let's say a dot strip. Okay, and let's print b. So b is actually everything without spaces, without the starting spaces and without the ending spaces. It does not hurt the spaces inside. So that's a strip function. Sometimes processing the data, when we read the data from a file, it may have a lot of spaces at the beginning, at the end, maybe due to formatting issues or something like so, and this function is available if we want to remove those spaces from beginning or from the end. Let's see more functions. Another function is lower. Like the name suggests, it actually converts all the string to lowercase. For example, let's say we have a string, let's say let's say we have a string a equals a, b, c, d, e, f, g, and some characters, some other characters, and q, f, let's say. That's a string. And now what we do is b equals a dot lower. What it does is it converts all the string to lowercase. For the characters that are already in lowercase, it doesn't hurt it. For the characters that has nothing to do with lower or uppercase, it doesn't hurt that. All the characters that are not in the lowercase and can be converted to lowercase, those are converted to lowercase, and this is available. Yeah, great. So similarly, we have another function called upper. For example, c is equal to a dot upper, that like the name suggests, it converts all the characters to uppercase. Wow. Let's see more functions. Oh, there is a function replace. The replace function, what it does is it takes a substring and replaces that substring with another substring. Okay, let's see it. For example, let's say we have the same a. Let's say the a is this thing. Let's say that's a. And what we want to do is we want to replace the semicolons, let's say, with the semicolon. We want to replace the semicolons with statics. So what we can do is we can say, okay, d equals a dot replace the semicolon with let's say static, or yeah. So let's see what d is. So each semicolon is replaced by a static. By the way, if you want to replace, for example, a dot replace, if you want to replace one semicolon with a string, for example, the string is star star and hat hat person person. That means one semicolon will be replaced by this with this string, and the other semicolon will also be replaced by this string, and the result will be as expected. Each semicolon will be replaced by this string, and that's the result what it is. Further, if you want, for example, let's say d equals a dot replace. If you want this particular substring that contains the two semicolons, if you want the two semicolons to be replaced by another substring, let's say two semicolons, that's it, then that is also possible. I mean, you replace one substring with another one. Yeah, great. There is one more function called split. That what it does, what the split does is, for example, you have a string, for example, let's say a equals a string, let's say abc, then you have this colon, then you have def, then you have semicolon, then you have hgy, this, then semicolon, then you have yy3223, and that's it. That's your string. Let's say you read that string from some CSV file and this appears, and now what you want all these values to be separated out that are separated by the semicolon. Maybe these are different values. ABC is a different value, then it is separated by a semicolon. Semicolon may be an indication or token that the next value started, and so on. Let's say you want to separate them. Let's say you want to just split them, all of them, with a particular splitter, and here let's say the splitter is semicolon. So what you can do is you can have a list and a dot split, and in the split you can specify the character that is used for splitting after and before we split that. And remember, the split function actually returns a list of strings where this is the first element of the list, this is the second element of the list, this is the third element of the list, this is the fourth element of the list, and so on. Because once you will split, you will be having different elements that are splitted out. So if you print, for example, L, you will be having a list of different strings, ABC and all that. Oh, don't worry about this single quote. The single quote and double quote is the same thing. Now we can access, for example, the third element or maybe the second element by index 1, and the second element here is DEF, and we can work more on that. Okay, is that it? I mean, are these the only functions that are available? Strip function, lower, upper, replace, and split function. Or is that it? That's all the string is about? Maybe there are more functions. How many functions are there in string? How can we use them? What are the total number of functions? Where is the list? Where is the documentation? Should we follow some book? Should we go to some tutorial and find all the string functions and see how to use them? Well, if you want to do that, you can do that, but there is another smart way. Let's say A is a string that you know. You write A dot and then press tab, and all the things that are there in string, they will appear in front of you. I mean, several things. You can go to this, you can go to that, you can go to that, and so on. So just you can check the documentation of A. For example, if you press A, then what it does, let's see. It's a string object and all that stuff. Fine, it's a string. So further, what we can do. So let's say A dot, we press A and then we press tab. Is there anything that starts from A? No. Is there anything that starts from B? No. Is there anything that starts from C? Yes. Capitalize, case fold, center, count. These are the functions that are available that starts from C. Okay, let's focus on capitalize. Okay, what is that thing? How to use it? Let's press colon, question mark, and see what this is and what it does. Okay, so here is the documentation. Here is the doc string. Returns a capitalized version of the string. Capitalized version of the string. Is that the same as upper? Maybe. So let's see. Now we know what it does. Let's just check it out. Print A, capitalize, and see what's the result. Oh, it's no, it does not capitalize the whole string, does it? The string A was, it does not capitalize the whole string. What is A? Let's see, what is A? A is the following string. A is the following string, so it does not capitalize the whole string. Oh, the difference between the capitalize maybe and the upper is that the capitalize, when it encounters no, capitalize just capitalizes the first character. Let me read the doc string again. Returns a capitalized version of the string. More specifically, make the first character have uppercase and the rest lowercase. Okay, that means if we have a string that has a mix of values, the capitalize will do the following. It will convert the first character to uppercase and all the rest of the characters to lowercase. Wow, that's an awesome function. For example, if you have string A, B, D, A, F, D, and G, G, Q, let's say, and then we call capitalize, let's say. So what that does is it actually capitalizes the first character and all the rest of the characters there as it is. And there are other functions as well. A dot, let's say count, what it does. A dot count, what it does. A dot count, what is that thing? Let's check it out. Or maybe we can check that out using help. What is A dot count? So let's see what is A dot count. It's a built-in function. Count method is an instance of, and it returns a number of non-overlapping occurrences of a substring. Sub in, oh my god, if you I mean, that's what is written there. Non-overlapping occurrences of a substring. Great. Oh my god. So basically there are a whole lot of functions of strings that are available. There are several uses of the string. There are several ways of molding and playing with the strings. Some of the functions are available. Some you can make your own. You can make your own modules on top of that to customize your according to your requirements. A lot of these are available, and you should know how to use them. First thing, if you want to do something with string or with any data type in Python, first check whether some method is available or not. And one way to go that is just right away from here. Another way is to go to internet and see, I want to do this in Python with strings, whether there is a function available or not. The good chances are there will be a built-in function that is available. And in that case, I will encourage to use that function rather than to write your own one, because using the built-in function or the method that is tied up there will be much more faster probably than the function you will be writing at your end, even if you're too smart in algorithms. So yeah. So that's about the string methods. There are so many other methods that are available. In the next video, we will see some more manipulation and processing and some more working with strings, and then we will move to other data structures. Okay, hope to see you in the next video. In the last video, we saw some methods of string, and these are just a few of them. A lot of them are available. We just discussed some of them. In this video, we are going to talk more about strings in a particular way. For example, what if you want to find out whether a particular substring is there in a string or not? Let's say you have a string and you want to know whether a particular substring is there inside a string or not. Well, you can easily find out that using the in keyword, and similarly not in means the reverse of that, or the complement of that or not of that. And in keyword always will return either true, a boolean, or false. If it is inside the string, it will return true. If it is not inside, it will return false. So let's check this, the implementation of that in Jupyter Notebook. So let's see. So let's say we have a string ABC, and we want to check whether this string is there in this particular string or not. So the return value is false because ABC as a substring is no longer there. A is there, for example here, AB is here, but ABC is no longer there. Yeah. So if we, for example, have an ABC somewhere at least once, then the result will be true. In the last to last video, or maybe in the very first video for strings, I showed you that you can use plus with strings. Can you compare two strings using less than or equal to? I mean, how to compare two strings, whether they are same or not. For example, ABC, let's say that's a string ABC. I want to check whether that string is the same as ABC or not. What will be the result? So the question is this double equal to can be used for comparing two strings? Well, the answer is yes. What will be the meaning of less than? A string is less than the other. Is that true? For example, ABC is less than, let's say, DEF. Is that true? If it is true, for example, what does it really mean? How can we define one string is, this string is lesser than the other string? Maybe this operator is working based on the length of the strings. But even if that, then this length is the same as this length. And to be more precise, we can change that length, for example, by just saying, okay, ABC, DEF, GHI, and I guess this string will be still smaller than the right string. So how this comparison is working? Well, I guess the comparison is working based on the alphabetic order, and you know the alphabetic order. A becomes first, then B, then C, and all the alphabetic order that is there in English dictionaries. That's how the strings are working here. And the alphabetic orders for all the special characters will also be defined in Python. For example, that's a special character, for example. Maybe this string. Is this string smaller than the following string. Yeah, return true or false. Because there is particular ordering in Python that is defined for these characters, that this becomes first and this, like A becomes first then B, B becomes first and C, and so on. So whatever the alphabetic order is, based on that order, you can compare the two strings, no problem. So these are also available. And the third thing is in function that is also available to check whether a particular string is inside, a substring is inside or not to in another string. One more thing that I want to talk about in that, for example, what if your goal is to print the following? Let's say you want to print the following: we are learning, and let's say you want to print the string in double quotes. We are learning string here. Let's say you want to print this. You want this string to appear in double quote. How can you do that in Python? Well, it looks like same. What's the difficulty? Let's call the print function and then just write here we are learning, then write the double quote here, string, and here. That's it. But there is a problem. The reason is when we call this, when we write this double quote, actually the string ends here. Exactly, the string ends here. And when we write this single quote and this double quote, another string starts here. And this is no longer a string. I mean, it has no data type inside. Well, how can we then insert these double quotes inside? Well, there are several ways. One way is to use escape sequence, and escape sequence is just like, it is, you use a slash and then whatever you use is considered as a character inside the string that is you're using. And now if you want another double quote, you use a character which is the backslash or maybe a forward slash. And if you use that, that means whatever that is coming in front of it should be used as it is, rather than considering that that's a special string defining symbol. Now in this particular case, you'll be having your double quotes available, and the backslash will be just out. It is just defining that don't touch this double quote. It has nothing to do with defining a string. It is just because I want to highlight this word. Another more easy way is to use the single quotes. For example, we are learning, and use the double quotes as a character inside that. Now the single quote, wherever it starts and ends, they define the string. Everything else is a character. We do not need a escape character where we want. Okay, great. And there are a lot of escape characters. For example, we have we are \n. That means go to new line. We are now on another line. So this \n actually puts everything that comes after to a new line. That's an escape character. Similarly, we have an escape character \t that actually inserts a tab whenever we want. So if we are, then a tab, then now on another line, now on another tab, whatever. So there are a lot of escape characters. I mean \n, \t, there are other. So it is good to know those. One more thing that is important, for example, let's say you want to print some address on the drive. Let's say C \, backslash or forward slash, whatever that is called, name \drive. Let's say you want to do that. And your goal was to just print that path. What will happen is this \n will be treated as a new line escape sequence, and \n will tell, okay, go to the next line and treat the rest of the things. But because \d is not any escape sequence, it is not listed inside, it is treated as it is, and that way this slash is also treated as a character. But here, because if this slash followed by this n, that's a combination that is already there for a new line, that is treated in a different way. If you want this to be used as it is and you don't want these, you don't want this behavior, you just want that all this should be treated in a very literal or raw sense, then you should just apply an R there. And R will tell, okay, that's a raw string, everything inside, just treat that as a raw string. There is no escape sequence inside. Great. So, and there is much more about string we can talk, but that was the most important that I told you, at least to me. We can explore this more. Actually, you should now explore this more. What are other functions of string? How can we play with strings in another way and stuff and so on. If I talk about strings, I can just, I can give a whole course on strings as well. But here I just give you a snapshot of strings. If you need more about strings, you should be searching on internet or seeing documentations and seeing basically what you want according to your requirements. Search the functions. Probably they will be available. Okay. In the next video, we are going towards list, tuples, sets and dictionaries, some other data structures that we were talking about earlier. We will be going to explore them in more detail from the next video. Hope to see you in the next video. A data structure, informally or in a very naive sense, is basically a collection of a lot of basic data types that contains data. One structure contains a lot of data. And we can define sometimes several methods and several specialized kind of functions are customized and defined just because of that data structure to perform efficiently. Different kind of, for different kind of tasks, we may have to define or we may have to choose different kind of data structures. The basic data structures that are available in Python is a list, tuple, set, and dictionary. These are the basic data structures that are available. We can create our own data structures if we want to, but most of the problems, almost all of the problems, mostly they are solved by these four basic data structures. Although a lot of these are not that efficient, there are efficient ways for customized kind of problems. We will see that efficiency when we will deal with the package NumPy that is faster than all of these. But we will see what kind of constraints are there to make it faster. Anyways, data set in a very loose term is collection. It is collection of a lot of values, a lot of data inside. And all these data structures, list, tuple, set, and dictionary, they are a collection of data of heterogeneous types, which means one value can be integer, another element, let me call it an element, another element or item. Another item or element can be of string type, another element can be of, let's say, floating point number, another element is a whole list itself, another element is a tuple, and so on. So different elements can be of different types. And that makes this heterogeneity, that makes these four data structures much more applicable and much more abstract, and they can be applied to almost all the problems. So let's see one by one and let's compare them together, because the best way to understand four of these is just to compare them, which can do what as compared to the rest. So let's compare them and learn how can we use those in detail. So list, first is list. List is ordered. Ordered here means it is indexable, which means there is the element number one is at position one element. There is an ordering of elements, first element, second, third, 25th element. There is an ordering of element with respect to their position. So that's what we mean by ordered. Changeable, or sometimes called more reasonable term or more usable term, is mutable. Mutable means once the list is created, as contrast to string, once the list is created, you can change its elements. For example, you can change the third element with another element, and that's perfectly fine. You can change it. That's what we mean by changeable, or more popularly called as mutable. Duplicates means the list can contain more than one element, more than, at the position number 3 you can have the same item, and position number 5 you can have the same item, so the duplicates are allowed. Tuple, however, although ordered, there is an ordering of elements. There are indices of different elements. This is immutable. You can, once tuple is created, like strings, once the tuple is created, you cannot change different elements in the tuple. You have to create a new tuple if you want to, but you cannot change the items in the tuple, and the duplicates are allowed again. Set, on the other hand, is unordered, which means there is no indexing, there is no positioning, there is no first element, there is no third element, there is no fifth element. That's a collection without actually indexing. Because you cannot access a particular element with index, you cannot change it, but what you can do you can insert more elements and you can remove existing elements if you want to. Again, the set, like in mathematics, sets does not contain any duplicates, so one item appears just once. We will see the examples. Dictionary, a very, very, very powerful data structure. Again, dictionary is just like a set. It is a set, it is unordered. Again, changeable. You can change them. You can change the items. And the dictionary, and it does not have duplicates because it's basically a set. It is just like a set. The power of dictionary is each item consists of a pair, and one value in the pair is called key and another is called the value. For example, val is key for 12, name is key for ban, and so on. So we have seen this dictionary before in loops and stuff in just a very loose way, but that's really a very, very powerful data structure. And later on we will see in Pandas, basically all the data is basically managed just like a dictionary. If you have a good knowledge of dictionary, you'll be having a very good grip very quickly on a big data science library or big data science package, which is called Pandas, because each and everything in Pandas is handled just like we are handling a dictionary. So it's a really powerful data structure to know about. So list is mutable, dictionary is mutable, set is mutable in a sense that you can insert and remove elements. Tuple is not mutable, and that's the comparison theoretically what is there. All these types, each and every of them is a collection of different values, and the values can have different types. That's the abstract power of all these data structures. So in the next video we will actually try to get a good grip on list, tuple, set, and dictionary, and we will actually define them, code them, access different methods of those, and we will be trying to become comfortable with these data structures by coding them in Python. So hope to see you in the next video. Okay, continuing previous video, we were talking about data structures in the last video. So let's go to the Jupyter Notebook and see how a list can be defined or declared, how a tuple can be defined or declared, set and dictionary. Let's see how can we make these data structures in Python. So then one by one we will compare how can we access elements of the list, how can we insert more elements in list, tuple, set, and dictionary, and see the comparisons of all these one by one, operation by operation. So let's see. So let's go to Jupyter Notebook, our friend. This file is getting lengthy. Let's make multiple files. Let's say this is part 1. Just save it, and let's make another file. For example, let's just close this file, or maybe stay it opened. Let's close this file and make another file. Python 3. Yeah, so let's name that file as this part 2. Let's start a new file. That file was, I mean, that was okay to stay with that file as well, but just let's make another file. Okay, so let's just have a markdown cell, and let's have a heading, data structures. Remember the markdown cells? I just introduced them introduce those just in the very beginning, and then we just forget them because writing these description again and again will make the video lengthier, and the purpose is not to actually format the notebook. The purpose is just to show you the power of Python. So I just omitted writing these descriptions more and more, but just write a few descriptions in the start and then we will forget again. Oh, that's amazing. Let's define a list. So list, any variable name, that's a variable name. List is, let's say this. You define list by square brackets, and different elements, they are separated by comma. Let's say 1, 3, 4.9, name, anything, I mean, or 5, or maybe 3 again. So that's a list. Okay. Tuple, on the other hand, is defined using parentheses. So let's say 1, 3, 4.9, let's say name, and let's say 3 again. That's okay. That's a tuple. A tuple is defined so when you write parentheses, that means by default that's a tuple. The variable name has, I mean, if you have written t, that has nothing to do that it's a tuple. That's because the Python is dynamically typed. When you will write the parentheses, that means the tuple is being defined. Let's define a set. Let's call the variable as s. The set is defined with these curly brackets. So let's say 1, 3, 4.9. I want to tell you that all these things, they can contain, each element can have a different type. But then even if we include this 3 again, because the set cannot contain the duplicates, later on we will see that only one copy of 3 will be there in the set, the other will, even if we want to include, it will not be included. Okay, then let's say a dictionary. Dictionary is again defined like a set, but each element is a pair separated by a colon. Let's say the key value is 23. That's a key value. That's a key, and the value here is a string. Let's say 2, 3. Let's say the value. Now comma. Now one element is there. This one element that consists of key and value pair. Another element. Another element may have a key with string. So the keys can be of different types. The values can be of different types. I mean, so abstract. So the key is, let's say B, and the value for this is, let's say 43. Then maybe we can have another key value pair with key as let's say C, and the value is, let's say CCD, let's say charge coupled device. Okay, anyways, so now you know how to define the list, how to define a tuple, how to define a set, and how to define a dictionary. The difference is the main difference here is in dictionary, because one element consists of 2 values rather than 1. Okay, let's print that and see the types. Let's print all the types. Print type of, so let's print them. The type of L is, so the type of L is, just print it. That's L. Let's print that. Let's see the other types. Let's print the rest as well. So just copy them and paste. The type of list L is that. The type of tuple is T. And let's say we have T. Then we have S. And then we can just replace this with S. And then we have, let's say, D, dictionary. And that's D. Okay, so let's print. So the type of L is list, the type of T is tuple, the type of S is set, the type of D is dictionary. Oh, great. So that's how you can define these lists. You can define list, you can define tuple, you can define set, and you can define dictionary. No problem. Next, let's see how to access different elements from these data structures. What are the way, for example, to access an element from a list? Let's say the element number, element that indexed with 1. Remember, the element that indexed with 1 is element number 2 because the indexing starts from 0. So you can access that using the square brackets. If you want to access from tuple, again from the square brackets, exactly like the list. In set, for example, you cannot index it because the set has no ordering. First, second, third element is no longer there. But you can check whether a particular element is there in the set or not using in keyword. In dictionary, for example, if you want to check whether a particular element, if you want to access value for a particular key, you just write the dictionary variable name and then write the key, and it will return the value. Okay, so let's practice this in Jupyter. Let's just practice this in Jupyter. So let's say list value at index 1. So let's print this list at index 1. The value should be printed as 3. Print tuple at index 1. Again, the way of accessing is the same. Print whether 3 in S or not. The return value will be true or false. So print will be true or false, and then print D and just access the value with the key 23. So let's see what happens. So L at index 1 is 3, T at index 1 is 3, S 3 is in S, yes. And what is the value with the key 23? The value is 2, 3. Let me just describe more about this D. What is the value at index B, for example? Now we have to give the index B in the string format. That's 43. Yeah. So that's how we can access that. Let's print S also. Let's see S, because when we have defined S, we have defined this duplicate 3. But if you see the elements of S, there are no duplicates, and it does not maintain even any ordering. I mean, we have defined S in a different way. It is maintaining everything maybe in a different way. 1, 3, yeah. Oh, the ordering this way is the same, but there is no index for the first or second or third element and so on. Okay, so that's about the defining, declaring, or accessing different elements. In the next video, we will see more about the data structures. Actually, I want to spend some time on the data structures because that will be a basic building block for the data science packages. To if we know very well about these data structures, we will be very fluent in the data science packages and working with those. Okay, hope to see you in the next video. Okay, in the last video we defined list, tuple, set, and dictionary, and we actually access different values. In this video, I'm going to actually introduce more indexing, how to access list and tuple, in particular because the both are very easily indexable like strings. And I want to show you that all kind of indexing that you have seen in strings exactly works in list as well as in tuple. So let's go to Jupyter and see what a list is. For example, a list, if you print the list, that's the list. It has these kind of values. If you just see the list, for example, starting from index 1, ending at index 3, that means the same. Pick a slice, for example. So index 1 value is 3, index 2 value is 4.9, and the last element is not included. So if you get that, you get 3 and 4.9. So exactly the same kind of indexing that you have seen in strings, exactly that is working here as well. So for example, if I say list, start from the beginning, go to end, but then I just give -1, it will reverse the whole list. I mean, the whole list will be reversed. I mean, all the things that we saw in string, the indexing stays exactly the same in list as well as in tuple. So tuple, for example, let's access element from let's say from the very beginning till the till the third element. Let's say, not the third element, till index 3, which is actually the fourth element. So tuple and list, they will be exactly indexed as it is. So all the slicing, all the indexing, all the sub listings, all the subtuples, they can be accessed exactly the same way as you've gone through the string. One difference here that I will explain later on, because list is mutable, it is changeable. I will discuss one thing, that when you slice it, when you get a sublist, then actually it refers to the same memory, and if you change the sublist contents, the actual list got changes. That is true for list in slicing, and that is true for sets and dictionaries in the copying the references and so on. So I will discuss that later on, but rest of the things are roughly the same as they're in string. Indexing is almost the same everywhere in Python. It has this kind of slicing is almost the same. If you know how to index strings, you know how to index lists. If you know how to index lists, you know how to index tuples and strings and everything. And by the way, if you know how to index string lists, you'll be very fluent in NumPy. That's the very powerful data structure. That's the very powerful kind of array processing package, with some differences that we will see. But even the indexing is same in Pandas when you are working with large amount of data files and stuff like so. The indexing is more or less the same that you've seen in strings. We will cover indexing, masking, and fancy kind of indexing in much more detail in NumPy, but this stays the same as you've seen in strings. Okay, so now can we expand the list? Can we add more elements? Can we insert more elements to the list? The answer is yes, because list is changeable, mutable. You can insert more elements. One way of inserting that is just to call an add operator. You just add plus and you just insert another list. So like two strings are concatenated by plus, two lists can be concatenated or combined together again by plus. But there is a faster function called append, l.append, that is sometimes faster than using this operator. We will see that. Tuple, because it is immutable, you cannot touch any content of the tuple. You cannot actually insert any element to a tuple. You cannot delete any element to a tuple. There are workarounds, for example, convert a tuple to a list, change it, then convert the list to a tuple. There are ways to do that, but tuple in its true sense, in the literal sense, it is immutable. You cannot insert any element, you cannot delete any element, you cannot change any element. However, you can combine two tuples together. You can concatenate two tuples together again by plus operator and save the result into a new tuple. That's possible. Set, you can insert elements using an add function. Add function allows you to just insert one element. If you want to insert more than one elements, then you can call an update function that actually accepts more than one element, that accepts another set that need to be inserted. That's possible. Dictionary, you can insert a new key by just d, new key equals to that. You just assign a new value to a new key and the key value pair is just inserted there. Great. You can delete or remove any element from the list using del command, del L1. That means this particular element is deleted from the list. That is possible. Deleting particular element from the tuple is not possible. However, you can delete the whole variable, whole tuple. That is possible. You can remove elements from the set using remove function, s.remove, and then you just give the element that you want to remove. That is possible. It will be removed. And you can delete the whole variable. That is always available. Similarly, you can delete a particular item from the dictionary by just calling the D of the value. For example, whatever the key is. So you call with the key and call delete, and it will delete everything. I want to mention here, to remove items from the list, there are other methods and functions that are also available. That I mean, there is a remove function, there is a pop function. These are available. Similarly, from removing elements from the dictionary, there are other functions that are available. But just to compare them together, I'm using this del command, although there are other ways of doing the same stuff as well. So let's end this video here, and in the next video I will show you all these operations that concatenating together, inserting more elements, deleting different elements. I will show you all these things in Python. So hope to see you in the next video. Okay, in the last video we saw how to insert different elements to different data structures, and for example, in the case of tuples it is not possible, and we also saw how to actually delete different elements wherever possible. So let's go to our friend Jupyter Notebook and see all these concepts in a running form. So let's go. Okay, so let's, for example, we have list. That's our list. Let's append an element to the list, or maybe more elements. That is L plus, let's say we can have another list, for example, how, or that's 6, and then U. That's it. And these two lists will be appended, and the new list will be as you can see, this. Similarly, we can append an item using append function. For example, 6.8. That will also be appended, and the list will contain these kind of values. So yeah, so both ways are fine. This plus is this plus can be used to append to lists, and this append function can be used to simply append a list with an element. Okay, great. Tuples, you cannot change a tuple, but what you can do is you can have two tuples. For example, T2 is a different tuple, let's say A and B, and let's say you have 45, let's say that's tuple 2. Then you can have a third tuple that is just the combination of tuple 1 and tuple 2. And in this case you have tuple 3, which is this. Yeah, so tuple 1 and tuple 2 are combined together, but you cannot actually insert into the same, the tuple is immutable. You cannot insert another element, you cannot delete the existing element, you cannot update any element, and so on. Similarly, S, the set, let's see the state of the set. That's the set.add function. You can add anything, let's say 56, that is added there, and the new state of S is this. Or you can call the update function, if you update method, if you want to insert more elements. For example, if you have multiple elements to be inserted, 23 game, and let's say you wanted to insert an element that is already there, so for example 1, then the duplicates will no longer be there, but the new elements will be inserted. Now let's see the state of D. The state of D is this. If you want to add another key value pair, you can add a key here. For example, a key might be new key, for example, new key, and the value might be for example, the new value. And now if you see D, the contents of the D has changed. Wow, that's simple. Yeah, great. Can you concatenate two dictionaries together using a plus operator? Is it possible? Is it possible to concatenate two dictionaries together? Let's say I have another dictionary T2 that is let's say the key is Y and the value is YY, and then we have another key, let's say z, and the value is let's say 10. Can I concatenate d and d2 together? Can I just update my d and add these values, insert these values also there? Okay, I left you with this question. You try to answer this, and in the next video I will answer this question, but try to answer this question yourself. And one way to try that is just to go in Jupyter and just type and check whether plus is working or not, or maybe there is another method and stuff like so. Okay, great. Hope to see you. Oh, I have not used the del, delete, and all that stuff and so on. So this question is there. Let me use the removing the elements. So let's say L is this list. If I want to remove any element, let's say element number 3, if I want to remove element at index 3, which is this string name, I can use simply this delete, and the L is everything but without that element. Similarly, I can remove, if I want to remove any element from S, I can call the function remove, and whatever I want to remove, let's say I want to remove game, and the game will no longer be there. Great. If I want to remove some element from dictionary, again, let's say that's a view of dictionary, I can call D, and I can remove the element with key, let's say C. Whatever the element is with key C, delete that element, and the dictionary has this particular state with this item. This particular item is gone. Okay, great. I can do that. But del is not the only way of doing that. There are so many methods. I mean, a lot of methods to do that. But just to compare all these, I'm just giving you the most similarities and differences wherever available. Okay, great. So I have asked you a question in this particular video. Can we concatenate two dictionaries together, particularly with a plus operator? If yes, then we are done. If not, then are there other ways and stuff like so? That's a question. So hope to see you in the next video with more on these data structures. Okay, I asked you a question last time. Can we concatenate this two dictionaries together with a plus operator? So what's your answer? Yes or no? The answer is no. Yeah. So we cannot concatenate them together. We cannot insert another dictionary to this dictionary using a plus operator because this plus operator is not defined for dictionary. What we can do is we can call an update function, because dictionary is also a set. I mean, a set of key value pairs, but at the end of the day it's a set with specialized function, of course. But we can call update functions and insert the whole new dictionary inside dictionary as follows. Yeah, so the answer is using plus operator, no, but there is a way using update method. Great. So next we focus on the copy function. The copy function is available for list. The copy function is available for set. The copy function is available for dictionary. So let's see the need of this copy function. Here I want you to be very careful because that's really important. Let's say we have a list. Let's say that's a list. And by the way, the same goes with set and dictionary as well, whatever I'm going to do with list. Let's say you have a list. Now what you do is you copy the list, or you just make another variable, like you can assign the value of L to another variable L2. What you do is that. Now L2 is this. Now these are two different variables. L is this variable, L2 is this variable. So you might be thinking L2 is separately completely a new thing and L is a new thing. You might be thinking that both are independent. But Python internally manages the data structures, most of the data structures, in a way that, because the data structure is a collection of a lot of data, it is consuming a lot of memory. What it does is, when you assign a variable or data structure to another variable, it does not actually copy all the contents. It does not actually make a new memory and store the contents in this. This variable also actually points to the same memory as this. And the consequence of that, if you change any value, for example in L2, let's say you change the index 2 value from this, the index 2 value is 4.9, now you're working in L2. Let's say you change this L2 value from 4.9 to, let's 4.9. Let's say you do that. So you might be thinking that this happens in L2. Well, in L2 that has happened. But what it also does is it does the same thing in L as well. So L also changes. The reason is L and L2, they both are pointing to this structure in the memory. And whether you approach that structure through L or you approach that structure through L2, you're approaching the same memory anyway. And that is called referencing. I mean, it does not create the data, it actually creates a reference in the memory. It actually creates a new name for the same memory. And both are pointing to or accessing to the same memory. And if you really want the behavior so that L2 becomes different than L, and whatever I do with L2 that should not affect L, then you should call copy function. L2 is L dot copy. Yeah, so that's the function, L dot copy. Now you have L2. Now you do whatever with L2, it will not affect L. So L2, for example, index at index 2, you again say, okay, this is 4.9. So L2 changes. Now L2 changes, but L doesn't change. L doesn't change. L stays the same. Now this has different copy. Same concept go with the set, and same concept go with the dictionary. If you just make another variable s2 and equals to s, then if you change the contents of s2, s will change. If you don't want that, then copy it. Similarly, copy the dictionary. Because the contents of the tuple, they are not changeable, the copy function is not available for tuple. Because even if you assign this t to t2, you can now not change t2 because it is immutable. So having a copy function doesn't make sense in tuple. Great. One more thing regarding slicing. Let's say you have L that's available to you like so. That's L, and let's say you make L3 another list by slicing. Let's say a list from, let's say 1 to 5. Let's say. So you start from index 1, which is 3, and you go to 5 by not including 5. This way, the L3 is automatically a copy. It is not a sublist which is referencing. So L3 is a different, L3 is a completely new list, a new memory view. If you change the contents in L3, for example, L3 at index 0, it should go from 3 to, let's say, 3. If you change the contents in L3, these contents, this change will not reflect in L. So if you do the slicing, slicing picks a copy by default. It does not pick a reference. And that's a huge difference between this list and a NumPy array. And we will see that when we will see a NumPy array, the slicing actually also again refers to the same memory location, and that might be one difference in indexing. Indexing in the whole Python, whenever you do slicing, you get a copy. But in NumPy, when we will see NumPy in detail, in NumPy when you do slicing, you get again a view, not a copy. And if you change in the sliced variant anything, the actual contents also change. And there is a reason to do that, and there are efficiency reasons to do that and stuff like so. Again, the .copy function becomes, the copy functions become much more applicable there as well. So you need to know that even if you do slicing in general in Python, in any collection, in any array, in any if you do collection for even for mutable objects like list, you get a copy. But in NumPy array, this particular thing with a lot of other things. This indexing scheme actually changes with this kind of slicing. Okay, so I end this video here. I mean, you can explore much more functions of list, tuple, set, and dictionary, and what you can do with each of them, and what you, I mean, in which scenario, what kind of thing is more suitable for the other. That completely depends upon the problem at hand. But what we can do in what we'll be doing in the next video, we will be seeing some functions of just list, and then I will be just letting you to explore the tuple, set, and dictionary and all their functions on your own, and to see what function or what method is doing what for which kind of data structure. So in the next video, we will be seeing some methods just for list data structure. Hope to see you in the next video. Like in strings, let's explore a lot of functions in list, although in sets and dictionaries and tuples as well, but many more functions are available in list. And by the way, let's see how many things are there in this list. Let's say l.tab, and tab will open up a lot of things for me. Append we know already, clear, copy we know already, count we don't know, count, extend, index, insert, pop, remove, reverse. Some of these functions they make sense by just their name, but let's see one by one. Let's see some of those, what they do. One way to do that is go to internet and see some book or tutorial or something like so. Another way is just write this, apply maybe help function, maybe apply a help function. It may help you how to use that. Great, this help function is great. So append an object method of built-in list instance, append object to end of the list. Oh, it appends an object to the end of the list, which means we may be able to append another list to a list. Maybe. Have we thought about that? The append method just takes one object. Maybe it takes a whole lot of list, but then it may be possible that a list is appended inside another list, and that whole list becomes one element, because list can contain other lists as elements. Well, that's a problem. Yeah. So let's see more functions. Yeah. So let's see clear. What this clear? What is this clear? What it does? Sometimes I use help, sometimes I use that. Remove all items from the list. Oh my God! If you call the clear, the list is empty. Okay. If you just call clear function on a list will become empty. Be careful. Okay, great. What else? So let's see. I have this function, maybe pop. What it does? Pop does what? So let's see. So pop removes and returns item add index, default is the last, which means if you also, that's a default value. Remember the default value? So if you call a pop function without an index, it will remove the index, it will delete the last item, and it will give you that, it will return that. Or if you give an index, it will remove that value at that index, and it will, after removing, it will return you that, so you can use it wherever you want. So there are many more functions. For example, you can see all of them one by one. Remove function, for example, reverse like the name suggests. If you call the reverse function, the list will be reversed. Yeah, and remember, we have reversed the list in the following way as well. We have a way of reversing any array this way. So now if you see, the list is again reversed. So I guess both of them are working like so, same. Similarly, you can explore several functions from a set. You go and say add, clear. Clear might be working as same as intersection and update, is disjoint, is a subset of the other. Yeah, add by default or update by default actually take a union. So I'm not seeing update function here. Where is update? Oh, union is there, update is there, which means the list you are seeing is here is not a complete list. You may be writing what are the functions that start from U, so here are they, and several others. Similarly, you can go to dictionary and call for several functions: clear, copy, from keys, get, items. Oh, that item might be interesting. What is this item? What it does? Oh, it has an error. What? So how can I use this? How can I use this function? Let's see. Oh, this is just an object. It is not a function. I don't know. Let's see again. Or it is not listed anywhere. Oh, it is items, not item. Okay, items. That's a function, maybe. So these are all the items. 23 with this, B with that, new key with that, and so on. Great. Actually, the purpose here is not to tell you each and every function and what it does. It will take a whole lot of time. You can go and explore all these functions. The purpose here is to tell you what kind of data structure has what kind of properties and what are the similarities and differences in between. So if you remember this one slide for list, tuple, set, and dictionary, and some text that is written out above, you'll be having very good knowledge of where to pick what kind of data structure in practice. So in the next video, I'll be actually going to Jupyter Notebook as our style, and I will be coding or solving some problem for you that will involve list, tuple, set, or dictionary, or one of them, or we will be choosing based on problem what kind of data structure is well and what. So we'll be doing that. But before that, I just want to mention that list, tuple, set, or dictionary, they can contain any items inside any kind of type, which means a list can contain another list. A list can contain a set, a list can contain a dictionary. A dictionary can contain a list which itself contains a dictionary. I mean, this is all abstract. This is all abstract. One thing can contain the other. One thing can contain an instance of, I mean, a list can contain multiple lists. And those lists can contain more lists and so on. Before actually going to problem solving, let me give you a flavor of that, how abstract these things are. Let me give you a flavor of that in just in a couple of examples. So in the next video, I'll be giving you a couple of examples based on the abstractness of these data structures. And from the next video, we will be doing some problem solving based on that. So next two videos are completely on Jupyter Notebooks. So get ready. Hope to see you in the next video. Okay, let's see the abstractness of all these data structures. Let's see just one example. Let's say we have L, that's the list. We have already tuple, that's tuple. Let's say we have set, that's set. Let's say, and we have dictionary, that's a dictionary. Okay, so let's say we have all these things, let's say, available somewhere. So let's make another dictionary. For example, let's say let's say D2, and that dictionary has key value pairs. Let's say the key is A and the value is the whole list L. That's the value. This is possible. Let's say the key is B and the value is just a tuple, the whole tuple. That's the value. Let's say the key is C and the value is the set. And let's say the key is D and the value is the dictionary, the whole dictionary D. It is possible. I mean, you can just do that. That is just one example. Oh, sorry. I should have incorporated this way. Okay, so this is possible. Now, for example, if I access the element with let's say A, I will get the whole list. And not only that, I can access the whole element, and then after that, for that element, I can access, for example, the third element, the element at index 3. So this particular first level will extract the list, and that is just the indexing or for that list. See, for example, if I access D2, and inside D2, if I access the dictionary that is inside, and let's say I save that dictionary in K, then I can see the contents of K, but I can just, for example, this, or I can just access all the elements of this dictionary or K by just having for X in K, print, for example, X and K of X. Just do that. I can just do that. We have done that in loops as well. So I want to tell you that these even if, for example, if you want to create a list L, let's say L3, let's say you want to create a list that can contain the whole list, that can contain I mean, one element is the list, another element is a tuple, another element is the whole dictionary inside, and then you have some other elements, let's say these game, and that's perfectly fine. I mean, you can do that. These data structures are much more abstract. I mean, now if you, for example, access element at index 2, which is dictionary, that is completely a dictionary. If you check the type of that element, that will be a dictionary object, and you can extract that element and play the way you want to play and whatever. One more thing, we can, for example, lists, we can let's say we want to make a list very quickly, for example, list of all the squares till starting from 0, list of all the squares till 10, for example, 0 square, 1 square, 2 square. Let's say we want a list of that. So one way of doing that is, a quick shortcut is to just use loops. So in loops, for example, we write, okay, x square for x in range 10, for example. So it will start from 0, go till 9, including 9, and you will get x one by one, and all this syntax is for making a list of x squares where x starts from 0 and go till including 9, go till 9 one by one, and that's how you can make a list. And I mean, these are kind of shortcuts. Again, you can make a set, for example, let's say you want to make a set of all the squares for x in range, let's say starting from 2 ending at 20, and you want to take a step of, let's say, 3. So start from index 2, go till 20, do not include 20, but take the step of 3, and you can now have a set which is this. I mean, there are a lot of ways of working with these. One can explore more and more about these things, but what the basic thing about these data structures are, they are very, very abstract. They can, I mean, a list can contain a dictionary, and that dictionary can contain a tuple, and that tuple have an element which is another list, and so on. It is that abstract. It allows you to do each and everything in that way. Okay, so I end this video here. In the next video, we will actually solve a problem using these one of these data structures, or we will try to choose one of those. And that video may be lengthy, may be small, because we may have bugs inside, and we will play around with these data structures in the next video. So do attend the next video, because it's really the practice, and you will get your hands. You will get a very good grip on the data structures in solving the next problem that we are launching for you. Okay, hope to see you in the next video. Okay, let's see a problem just to get comfortable with these data structures. So let's design some problem and solve that problem here using these data structures. So the problem that I'm thinking is, let's say the following. Let's say you are a teacher. Should I type all these things? Okay, yeah. Let's say you are a teacher. You are a teacher and you have different student records containing ID of a student and the marks list in each subject where different students have taken different number of subjects, and all these records are in hard copy. You want to enter all the data in computer and want to compute the average marks of each student and display. That's the problem. So the problem, let's say, is you have, for example, you have a hard copy, you have some papers upon which you have different students. Each student have a different ID. Some students may have taken 7 subjects, some student may have taken 3 subjects, some student may have taken 8 subjects, and so on. Different students may have taken different subjects. Records is there. You want to first enter for each student, you want to first enter the records, I mean all the data that is in, and then you want to compute from that data, you want to compute the average marks of each student. For example, if a student have taken 5 subjects, then the marks for all the 5 subjects are available. You just add all the marks and divide by 5, and that's, let's say, the average marks. So first of all, let's write a way to compute, for example, to just collect the data, how to collect the data. So let's write a function for that. So let's say define a function, let's say get data from user or teacher, let's say, and let's say that's a function and it returns data. Okay, so what I do really is I say, okay, while true, I made a loop while true, just take the data from the user, and the data is in the form of you first say, okay, ID, student ID, let's say that is enter, or actually input, enter student ID. So he enters the person enters the student ID. Yeah, so on top you might have defined a dictionary, maybe a dictionary D that is empty right now, but you may add and remove different values. So what you do is you add a student ID, you get a student ID and in the string form, and then you get the for example the input as the marks list. So marks list as input, enter the marks by comma separated values. So enter the marks using, for example, if you have 5 subjects, just write the 5 subject marks by separating each with the comma. Okay, then let's say more students is equal to, let's say, input enter yes or no for adding more students. So if, for example, you have more data to insert, then press yes, otherwise press no. So that's, for example, our setup. So we will keep on getting more and more, we will keep on getting more and more data from the user. User will keep on entering the data. But one thing that we must know is that if, for example, a student ID is already in D, if that is already in D, then we should give a message, print that student ID is already inserted. So that might be a message. Else we want to do something. Else what we want to do is the following. What we want to do else is we will make a dictionary. We already have a dictionary with the student ID as our key. That's our key, and at that key what we do is we pick the marks list and just split it using comma, because we are expecting, and all the marks, they will be saved as a list. So that will return a list of string values. These are not integer values, these are string values, but all these lists, they are tagged by this ID. So that is a dictionary that will be getting populated on and on and on. Further, if we check if for example, more students dot lower, for example, let's call the lower function because the user may enters it in a lower form, or if that is equal to, let's say, no, if that is equal to no, if this is the case, or if that is no, enter, for example, no, enter no, enter no to quit insertion, enter no to quit insertion. So let's say that's your message. So wherever the user inserted, if that's a no, then you return D and that's it. Otherwise you keep on moving. So that's the whole code. So you keep on asking you keep on asking more and more values. If whenever the teacher enters a no, then you just return. Otherwise you make another iteration, and keep on moving. That's how you get the data. So the data will be available to you once you are done with that. Then after that, we will see how to, once we have this data collected from the user, then we will see how to compute marks for each student individually, average marks and so on. So let's just check whether this function works or not. So let's say we have our dictionary. Let's say student data is equal to get data from user. Let's just call that function and let's see what happens. Okay, enter student ID. Let's say ID is 12. Okay, enter marks by comma separated values. Let's say 12, 1, let's say 24, comma 65, comma 87. Let's say the first student just have these 3 subjects. Then enter no to quit, so I will enter something else. And oh, what's the problem? There is a problem. If more students dot lower is more student is not defined. More student, that's, I guess, more students, more student here. Oh, the spelling mistakes, that's a huge mistake. So I just copy there, these bugs are there, that's part of life, part of programming life actually. So I guess now it will work. So let's do the process again. So 12, let's say, and the marks are 56, 45, let's say a bad subject with, let's say, 13. Enter no to quit. No, I will enter something else, and I will keep on moving. The other student is, the student ID is 45, let's say, and the marks that this student has gained, actually, let's say the student has already registered 7 subjects, or let's say 5 subjects, and the marks are, let's say, 44, 55, 66, 77, and let's say a bad subject, let's say 4. Okay. Then enter no to quit. No, I want to insert one more, so do anything else other than no. So student ID, let's say now the student ID is 12 again. Let's say I want to insert another ID again, and whatever the marks, let's say 45 and 45 again, let's say. Now enter no to quit, no something else. But now the message is there, the 12 is already inserted because the ID, the key value in dictionary cannot repeat, and so is the student value. So it does not inserted because this may be my mistake. So it asks again. So now let's say I enter ID, let's say 23, that's the ID, or maybe a different ID. That's the ID, and the marks are, let's say, 45, 45, let's say, and enter no to quit. So let's say I enter no, and that's it. So now I have received the student data. If I show you the student data, that student data is student data. That's a dictionary. That's a dictionary with key 12, and that's a list. But this list contains all the values that are string type. We will see how to handle that. That's a 45 as a key value. That's ID, and that's the marks list, and that's the ID, and that's marks list. Okay, great. Now we have student data. Let's write another function that helps us working on the student data. Basically, we want to find out the average marks of each student, and then we want to print those. So let's define another function, get average marks of each student, and that function actually receives this dictionary. Let me call it as D, any variable, that's a local variable. Okay, so what we want to do with that is the following. Average marks for each student. So we will define another dictionary. Let's say average marks dictionary. Let's say that is empty in the beginning, maybe. And then what we do for x in D, let's iterate over x and D. What we really do is we go to, we find out the list of located at L, located at X. So L is basically D sub X. So let's say that's our list. That's our list that is located there. So then what we do for I in L, so for all I that is in L, or let me call it for marks in L, in this particular list, what you do is you actually have this sum. Oh, sum is equal to 0. Right now there is no marks, so what you do is s plus equals to marks, but convert the marks to integer because they are already in string format. We have saved everything in string format. So you populate all the list. Once you're done with this loop, the S will contain the sum of all the marks. Then what you do is you compute the average and just save that average in AVG marks dictionary, let's say, or average marks. Just don't use the word dict, for example. You can, but let's stay casual. And at X, you just write the average marks, and the average marks can be computed by S divided by length of the list, whatever the list is. So that's what the list is. Yeah, so that's the average marks. And once you have, and one by one, all the average marks will be populated. And once we receive all these, we will then we can then just display by populating the average marks. So let's see. Let's call that function. So let's call that function. So AVG marks, for example, equals to get AVG marks, and let's put the student data inside, and if there is no error, then it will return everything. Then just print the average marks for each student for X in AVGM. Print, let's say, student, and then print X got average marks as, then you just print okay, AVGM of X, X, and that will display everything. Oh, if there is an error. None type object is not iterable. None type object. Why none type object? We have done some mistake. Yes. Maybe. Let's see. Let's see. For example, when we have run this. So let's run this and create a cell. Let's run using Alt Enter. It will create a cell. Average M. What is that thing? Oh, that is nothing. Why? Oh, we haven't returned anything. That's a bad programming, really bad programming. We have not returned actually the value that we need. So the default value is none. Great. Actually not so great. Okay, great. Yes, this. And now we have something in average marks. Yes, this is. And now we can just populate that, and we have the student 12 got average marks 38, student 45 got average marks 49.2, and student 23 got average marks as 45.0. Okay, great. So that was just a review of split function of string, type conversion through int, and functions in general, input function, and dictionary and list and all that stuff. So although it was just a tiny problem, but it gives a good flavor of the data structures and strings and all that stuff. Okay, that's about the data structures. From the next video, we are actually diving into the data science packages, and we will start from NumPy, and we will spend some time on NumPy, and then we will be moving towards Pandas, which is very, very powerful, built on top of NumPy. And after that, we'll be moving towards Matplotlib. And we will also try to give you some snapshots of scikit-learn as well. So hope to see you in the next video. Okay, the next few videos I will discuss NumPy, which is the very, very popular package for numerical Python. Actually, NumPy is like list, but it is much, much faster than list. One restriction, if we restrict a list, remember a list actually is a collection of a lot of data objects that was so abstract as we saw in previous videos. If, for example, we restrict a list that all the objects, they must have same type. All the elements in the list, for example, they have same type. Then that list with all the same type, that is what the NumPy looks like. But NumPy is way more faster. And the reason is, even if you define a list with all the elements that are, let's say, of same type, but because list in abstract way can handle heterogeneous kind of objects, the functions that we will apply on these items, they will no longer be faster. Further, to store each element, we have to store the information or metadata for that element. In NumPy, it is both. It is efficient with respect to memory, because if the type is same, we need not to save information about each element, because we need just to save the information about the type, because the type is same for all elements. Further, when the type is same, we can write functions that are much more faster than a list. So NumPy is very popular. It has very fast universal functions available, the methods that are available in NumPy, and it's a package. It's a whole directory structure containing a lot of packages inside, a lot of modules, and so much. At the end of the day, it's simply, or in layman terms, it is like a list with all the same type objects, and it is much more useful when all these objects are numeric type. Although you can have a NumPy array with string data types, all the strings or all general objects as well, but the power of NumPy array will become much more evident when we will be working on numeric type data. So in this particular course, we will focus more on numeric data than other kind of data. So that's how you write import. NumPy is installed, or if you have installed Python using Anaconda, NumPy is already installed there. It is in the side packages, kind of a built-in package. So import NumPy, we can stay as it is, but we can rename this NumPy just NP, that's most popular name. We can write any other name, but if you see the books or internet or somewhere, this NP somehow becomes much more popular. Okay, now we can define an array, for example, np.array. That's array is just a method of np, kind of function. And we can define an array using list. This is the list of several numbers. Or we can define array as a tuple as well. So whether we give a tuple, whether we give a list, an array is defined, and then we can see the contents of this array, this NP array. So let's just go to our friend Jupyter Notebook and get our hand well gripped on this NumPy. So first of all, we need to import NumPy package, and we may rename as, for future use, as NP. So let's say that is imported. So now let's say A is an array. Let's say np.array. That's a function, and we may have a list inside. Let's say 1, 2, 3, 5, 7. Let's say that's array. We can also define the array using a tuple rather than a list. It's our choice which way we define the array. Either way, 2, 3, 5. Let's say that's another array, for example. So if we print, for example, A, it will give us A, but if we just see the type of A, it will no longer be a list. It will be an ND array, numpy.nd array. That's an n-dimensional array. Okay, great. So there are so many attributes of this A and this B. Similarly, if we see the type of B, although we have defined this B using a tuple, but the type is the same. It's a NumPy object rather than a list or a tuple. So that's how you can create the array. One more thing that is important is to check the attributes of A. For example, A.D type, that will tell us the data type in A. So for example, A stores all the data that is integer 32. At define time, for example, we can specify the data type if we want. We can specify D type if we want. For example, integer that means A is integer. Here we can define, for example, D type as float, for example. So data type becomes float. There are several other options that are available to define the data type. But even if we don't define, the data type can be defined automatically based on contents. That's what the dynamic typing means. So if we now define type, that's this. If we now check the type of A, that is again integer 32. But if we check the type of B, D type, that might be a float number. Yes, that's float 32. Again, there are 64-bit support as well. I mean, we can define here. There are several options here available. So that's how we can define the NumPy array. That's just getting started with NumPy array. In the next video, we will play with these arrays a bit more. So hope to see you in the next video. Okay, in the last video, I introduced NumPy and we actually declared a NumPy array using a list as well as a tuple. In this particular video, we will be seeing some of the properties of the NumPy array variable, or sometimes called the object, that variable. So there are several properties, but I will discuss, for example, last time I discussed one property which is D type, a.d type, and that actually stores the information of the data type of the elements of the array, of NP array. Remember, NP array, all the elements of NP array, they must have same data type. It cannot store heterogeneous arrays as it is. Okay, now there is another property sometimes called the dimensions, or ndim. That tells actually what are the dimensions of the array. I need to explain this term dimensions with the following example. Let's say, for example, that's an array. Just consider that's a list, for example. 1, 2, 3, that's one list. And if it is an array, for example, if this is np dot array, with that list, we will say that array as a one-dimensional array because we only need one index to access that. For example, if you need to access any element in this array, you only need one index, either 0, 1, or 2, only one index. That's okay. So in this case, we have just one-dimensional array. On the other hand, for example, if you see here, that's one array or one list, that's another array, another list. And that's another list that contains lists inside. For example, let's say that's array 1 and that's array 2, and that is simply an array of two different arrays. That's an array and that's an array. For example, A1 is this array and A2 is this array. Now, if we need to access any element in this particular array, we need two indices. First of all, we have to locate whether we are going to talk about A1 or A2. We need one index for that. For example, if we want to locate A1, that means we are going to access with element 0. Let's say this whole array is A. So first of all, we say OK. 0 means we are going to access from A1 and A2 one of those. So 0 means the first one. Okay, now A1. Now inside A1, which element? This is the 0th element, this is the first element, this is the second element. Let's say we want to access the first element. So that means we are going to talk about, this. So very loosely speaking, the total number of indices that are required to access an element inside the array is called dimension of the array. An ndim that actually defines that actually describes this property, the total number of dimensions. Consider, for example, this is a 2D array or two-dimensional array. Let's say that's a two-dimensional array A1, and that's another two-dimensional array A2. That's another two-dimensional array A3, for example. And let's say this is an array of two-dimensional arrays. Let's say np dot array. Now that whole array, whatever that array is, a three-dimensional array, and the reason is to access any element, we need three indices. First index will define which one of these we are selecting. For example, let's say we are selecting that. So one index is needed. That index is 1, for example. Then inside this structure, like so, we need 2 more indices to locate a particular index. For example, because A2 is a 2-dimensional array, it has 2 1-dimensional arrays. So which 1-dimensional array you are, it has many 1-dimensional arrays. So which 1-dimensional array you want to pick? Let's say the 6th one with index 5. Now you have located the 6th array. Now in that array, what element? Let's say the 8th element. So we need 3 indices to access a particular element. So the dimensions of this array is 3. So let's play with that in Jupyter Notebook just to get more comfortable with the term dimensions. So let's say, for example, we have an array A. Let's say A is np.array, and let's say it contains a list, let's say 1, 2, 3, and then we have another array, 1-dimensional array, let's say 4, 5, and 6. That's another array, and that is an array of these 2 arrays. So that is basically a 2-dimensional array. It is array of arrays, list of lists equivalently. So that's A, for example. Oh, what's the problem? Oh, we haven't imported NumPy. We should have. So import NumPy as NP. Okay, we need not to import that every time. Actually, I'm recording this video after a few hours, and I have restarted all these things, so I have to import now for the first time. But once imported in the notebook, as long as the notebook is running, you need not to re-import anything. Okay, so a dot, for example, ndim, so that is 2 here because there are 2 dimensions. For example, if I want to access element number 3, this element, so this element is located in the first array of the 2 arrays, which has, so the first array, there are 2 arrays with index 0 or 1, so I am going to look into the first array, which is 1, 2, 3, and in that array I'm going to look for the element number 2, element with index 2. So that's how you can access the elements of multi-dimensional arrays, or arrays with more kind of dimensions. Let's say we have another array, just to get more familiar with, np array, let's say, and we have a list, and that list actually contains 3 1-dimensional arrays. Not only that, actually, I'm confusing you a lot. Let me just, let's say we have 1, 2, 3. Let's say we have 3 1-dimensional arrays. Let's say we have another 2, 4, 5, 9. The sizes of arrays maybe different. Yeah, is that true? Maybe different? Yes or no? Let's see. For example, the first array has size 3, and the second array has total size. Is that okay? I guess yes. And now if we want to access, for example, an element with let's say I want to access this element 5. So that is in the second array indexed with 1, and then in that array it has index 2. So I've accessed this element. Oh, why not? Too many indices for an array. Why? Why is that? Why too many indices for an array? B. So let's say b dot ndims, and then that is 1. Why 1-dimensional? I have I have this 1-dimensional array, and this is another 1-dimensional array, and I have made a list out of it. I mean, this is 1D array and another 1D array. I've concatenated them together. So I should have accessed this element. The problem is, when you are going to define multi-dimensional arrays, the number of elements for each dimension, they should stay consistent. For example, if the first array has 3 elements, the second array must have 3 elements, or if the second array has 4 elements, then the first must have 4 elements. If that is not the case, the array will not be defined like a multidimensional array. For example, if we, for example, extend our first array with, let's say, -1, now B will be having 2 dimensions, no problem. And now we will be able to access, for example, this element 5 like so. So we will go to B again. We will say, okay, select array number 2, and in that array, select the value indexed by 2, which is 5. So accessed, no problem. And that stays true if you're going to define, for example, a 3-dimensional array. Let me just give you an example of 3-dimensional array. Let's say C equals np.array, and let's say we have 1, 2, and 3, and then we have another array, for example, 4, 5, 6. Remember, so let's say we can have one more. For example, we can have one more list. Why not? So let's say we have 0, 0, -1, let's say, and that is a 2-dimensional array. Yeah, that's a 2-dimensional array. Great. Let's say we have another 2-dimensional array. Let's say we have another 2-dimensional array with same kind of consistency, the number of elements and stuff. Let's say these elements are all minus of the other ones. Let's say this minus, 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 and this is +1. And now we have this, if you see this thing, that's a 2D array, that's a 2-dimensional array, that is also a 2-dimensional array. An array of 2-dimensional arrays is basically a 3-dimensional array. Now that's a 3-dimensional array, this one, C. So if you, we have some, I should have defined this with commas rather than spaces. Actually, yeah, the reason I did that is MATLAB, I worked in MATLAB also, so MATLAB allows this space separated lists, but I just confused the things with Python as well, but Python requires comma there. Okay, with MATLAB, by the way, just as a side note, MATLAB allows you to have commas as well as spaces, but this Python just restricts everything to comma. That's great. Okay, that is C. So now if you check C.ndim, that is 3. If you, for example, want to access this particular element, what should you do? First of all, you select the one of the 2D arrays. There are 2 2D arrays. So this is the first 2D array, and that's the second 2D array. And if you, for example, want to access this particular element, which is -3, if you want to access that, you first have to access one of the two-dimensional arrays. So let's say I access the second one with index 1. Now you are in this particular 2D array. In that array, which 1D array you are talking about? So I'm talking about the very first 1D array. So the very first 1D array is indexed by 0. And in that 1D array, which element you are talking about? So I'm talking about this element that has index 2 in this particular array. So now if you press enter, you will get -3. Wow. So that is basically how, and by the way, you can make a 4-dimensional array. A 4-dimensional array will be an array of 3-dimensional arrays and so on. You can make, for example, n-dimensional arrays. And that's one reason why we call this as ND array, n-dimensional array. Now, the type of C is ND array, n-dimensional array. You can add as many dimensions as you want. Great. We will continue exploring this NumPy more and more in the upcoming videos. In particular, I will talk about this shape property of this NumPy. We have already discussed D-type. We have discussed ndim. In the next video, we will talk about shape, and we will discuss more about the NumPy. So hope to see you in the next video. Okay, in the last video we discussed this number of dimensions or ndim property of any NumPy array, and we also saw an example of defining a three-dimensional array in Jupyter Notebook. Let's discuss another property which is the shape property. Let's see what this shape actually represents. So let's go to Jupyter Notebook and see what actually this shape represents. For example, you have seen this C as, in the last video, we defined this C as a three-dimensional array that contains two arrays of 2D, and each 2D array contains three 1D arrays, and each 1D array contains three elements. So what do we mean by shape? So if we just say shape, what is that thing? So shape is 2, 3, 3, and let me tell you what that means. The return is tuple, so that's a tuple that is returned 2, 3, and 3. This 2 means how many two-dimensional arrays are there. Here we have 2. So in each two-dimensional array, how many 1D arrays are there? Well, 3. In each 1D array, how many elements are there? Well, 3. So basically this C.shape 0 tells you the total number of two-dimensional arrays, that is 2. And this shape, for example, 1 tells you in each 2D array how many 1D arrays are there, these many. And this shape, for example, 2 tells you in each 1D array how many elements are there. Well, 3. Great, that's awesome. Yeah. Can I tell you one strange kind of thing? You can define a NumPy array, for example, A as np.array with just one element. Let's say 2. That's an array. Great. What's the number of dimensions here? What do you think? What is that? Is that a 1D array? What are the number of dimensions? Strange. It's a 1D array. Yeah, it is. See another thing. For example, b is equal to np.array, and you define it with, let's say, 3. And what are the dimensions of b? It looks like the same. The dimension of b should be 1 as there. The dimension of a is 1. It looks like the dimension of b is also 1. No, it's 0. Because that's an array. If you pass it as a list, it's an array of 1D. If you just define just one number, that can be defined as an array. NumPy allows you that, but that one number is just a 0D array. Now, if you concatenate a lot of 0Ds, you get 1D. If you concatenate a lot of 1Ds, you get a 2D. If you concatenate a lot of 2Ds, you get a 3D, and so on. Get a look and feel? Yeah. So that's what it is. So yes, in this video I discussed the shape. There are so many properties. Let me discuss some properties. Let's say size. That actually tells the total number of elements, complete total number of elements in the array. So how many elements are there? That is size. There is also, I guess, n bytes property that tells the how many total number of bytes that this structure is taking inside the memory. And there are several other, properties. If you just apply a tab and get certain things, you will see a lot of functions, and you can check a lot of properties. That some of these functions we will explore later on. Sometimes they are called the universal functions. We will see them because they are very, very fast. And these functions, the vectorized implementations of these functions, that is the reason why NumPy is so fast and why it is so popular. Anyways, so in the next video we will go to explore the NumPy a bit more, and we'll show you more fun stuff with NumPy. So hope to see you in the next video. NumPy actually provides a lot of functions to create arrays, special kind of arrays, just for testing, and sometimes just for there are a lot of ways to create arrays from scratch. For example, what if you want to create an array containing all zeros? So there is a function in NumPy, np.zeros, that tells you how to do that. Similarly, if you want to generate a lot of generate an array containing a lot of ones or all ones, there is a function to do that, and stuff like so. There are some functions that are actually used a lot, and I want to discuss those. One function is np.arrange. Actually, this is a single R. This is not a two R's. This is a single R. np.arrange with one R. And np.arrange function, what it does is it creates an array. For example, if you say np.arrange, it creates an array. For example, if you say okay 100, so it creates an array that it creates a 1D array that starts from the values in that array starts from 0, 1, 2, all up to 99. So that's an array. That's a quick way to create an array with all the numbers till 100. Yeah. So let's see a running example of this np arrange method in Jupyter Notebook, just to get a better look and feel of how it works. So let's see. So let's say we have a equals np.arrange and let's say 100. So that's it. If you want to see what is inside a, you can see this is an array with all the values starting from 0 up till 99. Maybe you want to create an array that starts from a particular number, ends at a particular number. Maybe those two numbers are different, and maybe this arrange function actually allows that. Let's say I want to start with 20 and I want to end at 100, and I want to create all the array that does that. So let's say this. So that's okay. Start from 20 and at 100, but the last element, last index is not included. That's possible. Last but not the least, if you want, for example, to start from 20 and at 100, and let's say you want to take a jump of 3, that's possible. Remember, does this resemble with something that you know already? Remember that? Yeah? Let me pause for a minute. Well, not for a minute, just for some seconds. Let me pause. Do you remember this arrange, np.arrange function? It looks like something like what? Remember that? For I in range, yes, for I in range, for example, start from 20, go to 100, take a jump of 3. Remember that? So it has some resemblance with range function. Yeah. Although range is an iterator. What's an iterator? Why I'm telling you that? Okay, let me tell you an iterator as well. Here, just spend a few seconds on this range function. You might be thinking, when we call this range, let's say starting from let's say range 10, you might be thinking that it returns a list of numbers starting from 0 to 9, but that doesn't happen. It returns nothing. Actually, when you actually call it, it returns just an object. When you call it in a for loop or somewhere, it progressively returns one by one, element one by one. So it returns an element, then it iterates and return another element. Then it never creates a list of elements. It never creates a list for you. That's awesome. Actually, it generates numbers. It generates the next number and the next number as you move on. So it saves a lot of memory. And these kind of objects, they are called iterators that iterate. They never create. But if you want, for example, to get a list, if you really want to get a list, then what you can do is you can call the range, let's say the same way, and you can just write a list. So provide me a list, don't just provide me an iterator, and that will give you a list. How cool is that? Great. Anyways, that was just a side note. It has nothing to do with this arrange function. Anyways, so np.arrange, it actually returns an array. It is not like an iterator. It returns an array, complete array, the way you want. So that's what this arrange is. It has resemblance with this built-in range function that mostly used in for loops. Okay, next let's discuss this np.random.permutation. np.random is a package. np is a package. It has a lot of sub packages inside. Random is a package. Random has a lot of modules. One module is permutation. There are a lot of other modules. So let's see this random. let's see what it does. So for example, let's say a equals np.random dot permutation, let's say permutation, and what I do is I say okay, np dot arrange, let's say 10. What it does is this np.arrange will return an array containing all the values 0 to 9. These are 10 values. And then this permutation function that resides in the package np.random, that is in the random package of np, it actually shuffles all the values and rearrange all the values in random fashion. And a will now be an array containing the same elements but in a different order, in a different random order. So let me now print this a. It will be having all the elements from 0 to 9 but in a really shuffled way, and that shuffling is completely random. Yeah, you see that? Sometimes you may call some function, you may want to write some function on arrays, and you may want arrays that do not have a particular ordering, that are just random arrays, just to test your code, just to test how it works on any kind of array. In that case, one way of getting a shuffled kind of array, one quick way is to just use np.random.permutation function. The np.random package does not only have this permutation, there are a lot of other functions. np.random, for example, np.random random.rand int, for example, rand int, that creates a random integer. That's for example, if I let me call this, and we have how can it be used. Okay, we can give a low value from where we start, we can give a high value, and it creates actually random integer starting from low ending at high. So that's how it can be used. For example, let me call it as np.random.randint, create a random number between 20 and 30, create some random integer, and it will return some random integer between 20 and 30. If you call it again, it may return some other it is returning 30 again, 29 again and again. Now it returns 29, 22. Maybe we want to generate random integer between 20 and 30, so it creates a random integer. One thing that you might be noticing, what is the return value? The return value is v, for example. What should be the type of v? What do you think? Is this v is an array? No, it is a number. It's an integer. The type of v should be an integer because it is returning a random integer. It is returning an integer, but it is selecting that integer randomly from 20 to 300. So it should be integer, and it is. Yes. Wow. Yeah. So we will be exploring some more functions in the random package of NP, and then we will be moving towards this fascinating function called reshape. So there is more to come for NumPy. So hope to see you in the next video. Okay, in the last video we saw a range function. That's a very useful function to just create a testing array and just see output of a particular operation or algorithm just on different kind of arrays. Further, we saw permutation function in np.random package, and we saw that this permutation function actually it reshuffles, it shuffles different kind of or if array is applied to this permutation function, it actually shuffles all the elements of that array in a random way, in a completely random way. Today we will explore this random package a bit more, and then we will see a reshape function, what that reshape does. Basically this reshape, for example, if you have an array, let's say array let's say we have an array with, let's say 10 elements, and if we call a dot reshape and we give, let's say 2 by 5, so it will make a two-dimensional array out of A, which is B, and that will be a 2 by 5 matrix, or that will be an array or a matrix with 2 rows and 5 columns. And now we can just work with this B just like it's a two-dimensional array, and we can just treat this B as a two-dimensional array and work with that. It becomes handy sometimes if, for example, we want to test certain operations on matrices. A quick way to make a matrix is just to call a range function, and then whatever the result is, just reshape it into the desired order matrix and test the algorithm. So let's go to the Jupyter Notebook and check this random package a bit more, and then see the reshape function. So let's go to Jupyter Notebook. Yes. So there are a lot of ways to generate these random numbers. One, for example, we already have seen rand int. Another way, for example, array A can be generated like np.random.rand function. So now if we create this, if we pass, let's say 1,000, a random value array will be generated in A, and each value of A will be a random number between 0 and 1. So all these numbers are just random between 0 and 1. Each number is 0 and 1 random number. And this distribution basically is the distribution of this random number is the distribution is uniform. If, for example, we want to plot the histogram or the distribution of A, it will look like uniform. Let me just give you one or two plots using Matplotlib package, although we will see Matplotlib package later on, but let's assume that this is just a plotting package. This is just a package that helps us plotting. Just import that, import matplotlib.pyplot as plt, import that, and after importing that, you just plot a histogram plt.hist, for example, and pass A, and you can see the histogram is roughly uniform. Everything is equally likely. We can make more bins. For example, we can have bins equals, let's say, 100, and we can see almost all the bins, they are just look like uniform. If we make more and more data set, then they will all look uniform. One more thing we can have, for example, this and let's say B equals np.random.rand n, and that generates normal random numbers or Gaussian random numbers, let's say, which the distribution of the numbers is the bell-shaped curve, for example. So let's just plt.hist B and bins, let's say, equals to 200, and we can see a bell-shaped curve because the distribution of this data is Gaussian distribution. It looks like so. So this random package is this np.random is really important package. It has it can create different kind of random numbers following from different distributions. And doing in machine learning or in statistics, sometimes we need to generate these kind of random numbers sometimes for testing purposes, sometimes for adding noise of a particular type to test our model and stuff like so. So it is good to have a good grip on np.random package. Okay, next we see reshape function. One more thing, for example, if you want to create, for example, a two-dimensional array of just random numbers, let's say you can call np.random.rand, and you can just pass two arguments, for example 2 by 3, and this C will be a 2 by 3 matrix. If you see the C, it will be a 2 by 3 matrix of all random values. If you see c.ndim, it will be having the dimensions are 2, and it's a two-dimensional array. Further, we can create, for example, a four-dimensional array. C equals np.random.rand, maybe 2 by 3 by 4 by 2, and that's a four-dimensional array with this particular order. So if you see this c.ndim, that will be this. Yeah, so let me just give you an interpretation of what that thing is. There are two arrays that are three-dimensional, and there are two of those. Okay, now each three-dimensional array has three two-dimensional arrays. Wow. So each two-dimensional array has four one-dimensional arrays, and each one-dimensional array has two elements in it. So that's what this structure is. Yeah, get a good look and feel. So let's see the reshape function. For example, let's say we have d equals np dot arrange. Let's say we have 100 values, and then we say reshape these 100 values to, let's say 4 by 25. So this D will be a 4 by 25 matrix. So if we just get the shape of D, so that will be a 4 by 25 matrix, or a two-dimensional array with 4 rows and 25 columns. Yeah, so sometimes we want to work on matrices, and we can just plug in these arrange function to generate a bunch of numbers, and then we can reshape those and build a matrix quickly, and then just test the performance of our algorithm or stuff like so. So not only the reshape not only returns the I mean, you can reshape a matrix, and you can reshape an array into more than two-dimensional array if you want to. For example, arrange 100, let's say dot reshape maybe as 4 by 5 by 5. It's a three-dimensional array. Now this D will be a three-dimensional array containing different values. Yeah, so now you can access it and do whatever you want to do. So not only the reshape, arrange, and permit random, there are other functions as well. np dot zeros, for example, if you press Z and you just see the zeros, and then you just press a question mark, you will know what that function is, how can we use it, and so on. Similarly, you can have several other functions. There is an important function ones, for example. You can call that function, and that will generate an array of all ones. You can see how to call that function here. There is np.empty, there is np.empty like. There are so many functions just to create some matrices very quickly, and you want to test your code or algorithms based on those. So yeah, so there are a lot of functions that we want to that we can work on. So next, so there are a lot of functions that can quickly create a NP array and an n-dimensional array. We can quickly create an array, test our algorithm, or use that array wherever we want to wherever we want to use, and we can move on. Just a few functions like arrange, ones, zeros, they are there, or random.rand, random.rand, n, and other functions, they are available. In the next video, we will be seeing the indexing or slicing inside NumPy array, and we will also be seeing the difference of that indexing with or slicing from the ordinary list or the ordinary data structures. What is the difference of slicing in NumPy with the, for example, with the list? We will see that in the next video. Hope to see you in the next video. Okay, here is my favorite topic in NumPy, slicing. Actually, indexing or slicing in NumPy is the way you access subarrays is just the same as the way you access substrings or sublists. And you already have seen how can we use this slicing or indexing in lists and in strings. The difference here in NumPy is in list, for example, if you slice, you get, for example, let's say b equals a 1:5. If you slice that thing from NumPy, then b is not a copy. It is actually accessing the same memory view as in A. Now if you change any element in B, the corresponding element in A will change as long as A is a NumPy array. However, if A is a list or any other data structure, ordinary data structure, then the slicing, this kind of slice, gives a copy rather than a view. So that's an important difference. We need to know that rest of the indexing technique is almost the same. You do this kind of indexing. That is how you can reverse. This is start, end step. All the things are same, except how can we play with the two-dimensional arrays. Let's see that. Let's see some examples of indexing one by one in Jupyter Notebook and see how the slicing actually creates a view rather than a copy. So let's go to our Jupyter Notebook and see how can we play with different indices. Let's say A is np.arrange, let's say 100, and let's shuffle them. Let's stay as it is. Let's say that's A. Now A, let's say, let's print some certain things. Let's say B equals A, pick all the elements starting from index 3, ending at index 9. So 10 is not included. That's B. Let's print B. Let's see what's B. So B is this array. Okay. Now what I'm going to do is I'm changing the contents of B. This NumPy array is mutable. You can change the elements inside, no problem. So I'm going to change the elements. Let's say one element in B. Let's say I'm going to change element number 0 in B, which is 3, and I'm just placing that element as -100, -1200. That's it. That's the case. Okay, now the contents of B has been changed. Yeah, but now let's see the contents of A. The contents of A also has changed. That's a big difference between slicing an ordinary list or an ordinary data structure or slicing a list. When you slice a list, you get another label, but that label or that variable is accessing the same memory. The memory actually is not copied. There is one memory view, and these two different names, whether you access those elements using B or you access those elements using A, the same memory is being accessed. If you change the memory using B or A, you will see the effect in both of the variables. So that's one difference. Now, after having knowledge of this difference, if we really want this behavior to not happen, one thing that we can call is we can say, okay, A, for example, A, let's say 3 to 10, and then we can call our famous function, remember that, copy. You can copy that, and now B is completely a different array. It's a different memory view. If you change B now, the effect will not be seen in A. So copy function is there whenever you need copy. One thing, if you are not going to change elements, the NumPy supplies you very fast implementation of slicing by not changing the memory view. If you are aware your algorithm is not going to change the elements, slicing will give you much efficient access to the elements or the sub blocks or sub arrays without actually making the copies inside the memory, which can take time and space both. So this is one plus of NumPy over the other data structure that we have seen so far in Python. Okay, let's play with indices. Let's say, what do you think? What is that thing? Colon, colon 2. What? Or colon, colon, let's say 5. What it will do? It will start from the very first index, which is 0. It will go to the last index, but it will pick every fifth element. So let's see. So it picks 0, then 5, then 10, then 15, because the jump is 5. Great. What do you think? What this will do? Let me just teach you by example what this will do. Yeah, what it will do. Remember, if you apply a minus here, the end and the start and end, they just get swapped, and this becomes a step from the end. So what will happen is the same kind of impact. You start from the very end, then you take the step of -1 from the end, and you just paste every element. So this is kind of reversing the array with kind of steps starting at the end. Great. So another way of reversing the array is, if you want to reverse the array as a whole, just apply -1, which means start from the end and pick every element from the end till the beginning. And and the array will be reversed. This element is there, remember that? This is there. Let's change that element. So A at position, so I want to find out the index where this minus 1200 is located. So IDX is equal to A dot index. I guess there is a function index. Yes and no. Index. Oh, there is no index there. Is there an np dot index? Np dot index. I want to find out the index where so index, there is no index function, indices or something. I want an index function. Is there any index function? I want to find out the index where minus 200 is located. There are several ways, but I want to find one. So for example, let me see whether there is an index function or not, available in NumPy or not. No, it is no longer there, but there is indices function, I guess. So indices, what that does, I guess that does the same job. Let me see. np.indices returns an array representing the indices of a grid. Okay, so I have to give a grid, and then it returns, for example, the indices of all that grid. How can I use that? Well, it becomes difficult. There may be a find function, or how can I locate the index where the minus 200 is located? How can I do that? Yeah, very difficult. Seems like very difficult. Oh, why don't I, rather than finding out a function, why don't I just play with the NumPy? Why not? So let's say A equals minus 1200. That gives me a Boolean array comparing each and every element with minus 1200. So the array, the returning array, let me call the index array, or the Boolean array, let's say B. That array is true or false array, or 0 or 1 array. Wherever there is minus 1200, that index is 1, that value is 1, otherwise it is 0, completely 0. And then what I do is I just multiply that with the np.arrange with saying that a dot size. So whatever the size of A is. So because these are the indices. Okay, then what? That's the pointwise multiplication. Great. So when I will multiply them together, what I will get is what I will get after multiplication. I will get how can I find out? Actually I'm lost here literally. How can I find out the index where am I? So that will give me what? Let's see. What is B now? The B is just an array. B is just an array, and there is this 3 that is located. So how can I find out where is this 3? How can I again, the problem is finding out the index. Okay, that's really a bad thing. Can I call this a dot indices and just give a minus 1200 and everything just worked out? No, there is an error. Oh, I'm lost here. Literally, I'm lost here. I need to know how to find out the index where this particular element minus 1200 lies. So that's a question for you as well. I'm also lost. So let's see you in the next video. And we first will solve this problem to finding out the index of a particular element, or maybe a lot of elements. And then we will continue from there onwards to see more indexing. Okay, great. So Hope to see you in the next video by first solving the problem how to find out the index of a particular element in a NumPy array, or maybe more than one elements in a NumPy array, and then we will be practicing more about these slicing examples. Okay, hope to see you in the next video. Okay, let's say this element is there, and let's say we want to locate that element in the array. We want to just know where this element is in the array. So array A has this element. Let me print array A as it is. This array A has this particular element, and we want to know where what is the index of this element inside the array. There are several ways of doing this. One way is to find out that index is simply you call the function argwhere, for example, argwhere A is equal to -1200. And that will return a 2D array. And if you just want any one index, then you return that kind of thing. So if you write this thing, you will get the index exactly of the element that is there. So the index is 3. If you want to change that value, for example, the value should be 3 here. If you want to change that value, what you can do is you can write okay, A idx is equal to 3, and A is reversed to its position wherever it was created. Okay, great. Now let's play with two-dimensional indices. Let's say two-dimensional arrays. Let's say we have A equals np.random rand. Let's say we have 5 by 4 matrix. Let's say a two-dimensional array. Let's round all the values by multiplying them to 10. What it does is, because all the values, this rand function, all the values it generates are the values between 0 and 1. What this multiplied by 10, what it does is it actually scales up all the values to 10, and then round function actually rounds the values to the integers. Now A will be what's the problem? Round method is no longer there. Okay, maybe there is np.round. Maybe that np.round. Maybe np.round is there. Yes, np.round. So round function of np. So this A is this array, for example. That's a 5 by 4 array, 5 rows and 4 columns. So let's say I want to access the second row. First of all, let's say I want to access this particular entry. This particular entry is second row and third column, which means the index is 1, 2, because second row means the row first has index 0, row 2 has index 1. Similarly, column 1 has index 0, column 2 has index 1, and column 3 has index 2. So that is what this particular entry is. What if we want to access the whole second row? For example, we want the second row. So that's how you slice. A normal meaning of this is the row should be 1 and the columns, all the columns. So that's how you access the whole second row. If you want to, for example, access the whole third row, for example, or whole second column, let's say, that means you say this, okay, the column number second and all the rows, which means the whole second column that is accessed. And that, if you see, that's the whole second column, 6, 4, 2, 10, and 1. That's what the second column is. Further, once you have you can for example access a submatrix. Let's say you want row number 1 to row number 3, not including 3, and then of these rows you want column number 2 to column number 4, let's say. And if you do that, you access the whole submatrix. First it actually picks row number 2 and row number 3, because row number 2 starts from 1, and then of those rows it picks these columns, and you can just pick the submatrix inside. You can do a lot of processing on these matrices. For example, this is matrix A. If you just type A dot transpose, that T is for transpose, the matrix just is taken transpose of it. Further, there is a complete library, linear algebra library in NumPy. For example, if you just import NumPy dot linear algebra as LA, for example, then this linear algebra library in NumPy has a lot of functions: eigenvalues, Cholesky decomposition, computing determinant of a matrix, finding out inverse of a matrix, and whatnot. For example, let's say we have LA dot inverse, and here is np dot random dot rand, let's say some 3 by 3 matrix. So what it returns is, it returns the inverse of this matrix. And this linear algebra library, and there are other libraries as well, but this is one scientific library that maybe most of data science experts who actually want to do research, they might be thinking this linear algebra library that specifies a lot of functions related to these matrices or two-dimensional arrays. So that is there. Okay, so that's about indexing. We can play with these indices a lot if we want. One more thing, just one last thing. Let's say this is our A, and what we want to do is, let's say we want to sort this A with respect to the columns. We want each column to be sorted individually. What we can do is we can call sort function, and we can pass x is equals 0. X is equals 0. That means sort all the columns individually, and the result will be, if you see the result will be every column is sorted individually. If we want to sort, for example, every row individually, we will say, okay, sort x is equals 1, and every row will be sorted individually. And if this is a multi-dimensional array, more than 2 dimensions, then x's can be 2, x's can be 3. So with respect to whatever x's you want your sorting can happen, it can do that. If A is one-dimensional array, then dot sort function without an axis just sorts the one-dimensional array from beginning to the end. And if you want a descending order sort, just sort it first and then reverse it using indexing. Great. I mean, there is a lot to discuss. I'm ending this slicing here. In the next video, I'm going to show you kind of masking, or sometimes called the fancy indexing, that is much more powerful and useful in a lot of different contexts. So hope to see you in the next video with more NumPy indexing. Okay, there is another way of indexing a NumPy array. In the last video we saw we can do slicing notation, for example, start from here, end at here, and stuff like so. There is another way of accessing a NumPy array, as we have an array A, and we can just give an index array inside. For example, let's say A is one-dimensional array, and then we just give 1, 4, 6. That means pick the element at index 1, pick the element at index 4, pick the element at index 6. So this kind of array inside can be a list or an array that is called an index array. And you can just pick the elements that you want to pick. For example, you want to pick all odd elements. You want to pick first element, fifth element, and 17th element. You can just create an index array and pass it and index and access your elements using that index array. That's possible in NumPy array. Further, you can access different elements using a Boolean mask as well. So Boolean array, for example, true, true, false, false. Wherever there is a true, pick that element. Wherever there is a false, don't pick that element, and return the elements that are picked. For example, assuming here that you have an array A, which is one-dimensional array, let's say, assume that has 8 elements, 1, 2, 3, 4, 5, 6, 7, 8 elements. Now you pass a Boolean mask inside where with obviously 8 elements, 8 true or false values. Wherever there is true, so pick the very first value, pick the second value, don't pick the third value, don't pick the fourth value, pick the fifth value, pick the sixth value, pick the seventh value, and don't pick the last value. So that is also possible in NumPy. One thing that is important is if you do this kind of indexing, which is sometimes called masking. If you do that, if you supply an array index or index in a Boolean form, you by default get a copy as compared to slicing. In slicing, you get a view that's a separate copy. You need not to call a dot copy function. It is by default a different copy. And this is a difference between the ordinary slicing that you do. For example, start from 1, go till 50, take a jump of, let's say, 2. If that is your indexing style, that is called a slicing. The return value is a different view having the same memory. However, if you use the array index or the Boolean array called masks, then you get a copy rather than. So which means if you get a new array, you change the elements in the new array using the array indices, you're not getting that change happen to the original array. So that's the difference between slicing and masking. Okay, this kind of Boolean indexing becomes really handy. For example, what if you want to get all the elements that are smaller than 8? One way to do that is just write a and then apply a condition. A is less than 8. Well, a is less than 8 will create a Boolean array, and everywhere where the element is smaller than 8, there will be a true, otherwise it will be a false. Now the inside array is a Boolean array, and you access all the elements with respect to that condition. So it will return all the elements that are smaller than 8. How fancy is that? Further, you can have these conditions in a combined way. There is one difference. There is an AND operator, A-N-D and there is an AND operator in a different way. So I'm going to discuss the difference of this and this AND as well in this video. So let's go to Jupyter Notebook, our friend, and see how can we play with this masks. So let's say A is again np.arrange, let's say 100. That's our A. And what we now do is we access the elements of A. We access, for example, the 3rd element and the 5th element and the 6th element. Let's say we want to do that, and that's our B. Yeah, so that happens, let's say. So what B is this. Something that you need to know is if you change the elements of B now, because that's a copy, let's say -4, that change does not happen in A. That happens in B for sure, but that doesn't happen in A. A does not contain any value that is -4, because using these kind of indices, the array index, by default, the result is a copy rather than a view. Further, let's say you have this A and you want to access all the elements that are smaller than, let's say 40. Access all the elements that are smaller than 40. So that is possible. Now B will contain only the elements that are smaller than 40, all the elements. Wow. Further, if you want to access all the elements that are smaller than 40, and they are bigger than, they are smaller than 40 and they are bigger than 30. Let's say you want to access all the elements that are between 30 and 40. You can just access those elements like so. There is a problem. A.any, A.all. What's the problem here? The truth value of an array with more than one element is ambiguous. Use A.any or A.all. Okay, this A is less than 40 is a Boolean array. A is greater than 40, that's a Boolean array. So what's the problem? Why can't we not use this? Or what's the problem? We should have used that. So use and yeah, I guess we were missing these brackets because it might be confusing this 40 with this A and stuff like so. So use parentheses. Great. Now B contains only the elements that are between 30 and 40. Now one thing, what's the difference between this particular and this symbol and? The difference is this and, A and the and operator, it is used when both of the sides of this and has one, is one object and it has one true value, either true or false. And this particular symbol is used when the left side and the right side can be arrays, and each element of that array can be true or false and so. So you can think of this AND is used in arrays. However, this is used when both the sides are single objects. So that's the difference. Other variants of AND, I mean, the AND is like this, that these are the same things. But remember the use. This is used for arrays. This is used for single objects. Similarly, there are other symbols like OR that is used this way, or that is used that way. Similarly, there is a NOT. NOT for arrays is used like this way, and NOT for otherwise is used like that way. So remember these, the left side kind of symbols, they are used for arrays. The right kind of symbols, they are used for single objects that has true or false values. So this kind of masking is really, really powerful. Later we will see in Pandas accessing different kind of data with particular kind of conditioning. That becomes really handy if we are comfortable with these kind of indexing, and that's really powerful indexing. Okay, I've told you the difference here between and. I've told you that this is copy rather than a view. So just bear with me some more time on NumPy, and I will tell you some more truths about NumPy, and then we will move towards another package called Pandas. So before Pandas, more NumPy is coming. Hope to see you in the next video. Okay, in the last video we saw masking, which is sometimes called the fancy indexing as well. And here we are going to discuss one more feature of NumPy, which is a very powerful feature called broadcasting. Think, for example, you have an array, let's say 2, 3, a matrix, let's say two-dimensional array, 2, 3, 5, and 9, and you want to add, in every element you want to add a number, let's say 5. So one way to do that is create another array with 5, 5, 5, 5, and just apply this add operator and you are done. Great. But this NumPy allows you to just write, let's say this is array A. NumPy allows you to just do this particular thing, and this 5 is automatically broadcasted to match with the dimensions of its other operand, and the addition happens. You need not to do this explicitly. And this broadcasting is not just one scalar value. For example, if you have one variable, let's say A is this, and you want to add, for example, this particular column, let's say 1, 3, you want to add this particular column in the first column as well as in the second column. But then you need this 1, 3 to be copied again and make a bigger array, and then you do that. Well, broadcasting allows you, if you just write this as A plus 1, 3, it will be automatically broadcasted to match the size of the other operand. Wherever the broadcasting is possible, there are certain rules to know when broadcasting is possible. It is not possible each and every time. For example, if you have this matrix 2, 3, 9, and you have 4, 2, 1, let's say this matrix, and you want, for example, 2, 1, and 6, 2, for example, if you want to do that, the broadcasting may not happen because in this way, if I want to broadcast this structure should be, if this structure is broadcasted to in horizontal way, the two columns will be added and the addition cannot happen. If it expands to a vertical way, still the addition cannot happen. So this here you will get an error because broadcasting cannot happen. But in several cases, when you want to add, for example, a scalar multiplier with a particular thing, wherever possible, this broadcasting is possible. And broadcasting is just it's just a feature of NumPy that allows you to not repeat to match the dimension of the other operand to apply a particular operator. It does it by itself. Great. Next, we see some more important functions to know. One is horizontal stack. That means if you want to concatenate two arrays that can be concatenated together horizontally, you can call hstack function, and that will concatenate the two arrays together and returns another array. Similarly, vstack is if you want to concatenate two arrays vertically if they can be concatenated vertically. Similarly, there is another powerful function, sort, and there are a lot of other functions. These kind of functions, they are called universal functions, and they are very, very, very powerful, very, very fast. Their implementation is vectorized. Vectorized mean the implementation, the all loop kind of layer is deferred to at the compile time, and the things are really faster when you do a vectorized code. So having said that, it is always recommended to not use explicitly for loops to achieve these kind of results. Whenever a universal function is available, use that, because the efficiency of that universal function will be way, way, way more than whatever loop or whatever function you will be writing other than the universal function. So, and by the way, there is another function, concatenate, as well, in which you can specify x's, and it will either act as horizontal stack or either act as vertical stack, depending upon whether the x's value is 0 or 1, whatever. So let's just get comfortable with these three functions just quickly in Jupyter Notebook and see an example of, let's say, broadcasting as well. So let's say we have a function, let's say we have an array A. A is, let's say, np.random.rand. Let's say that is 2 by 3. And then I just multiply this with 10. Remember this thing, and then we just np.round. We just round everything so that it becomes whole in this particular way. Okay, that's A, let's say. So that's our A. That's the, now if we say A plus 3, the 3 will be added everywhere in A, and that happens through broadcasting. Wow. If we do, for example, A plus, for example, np dot arrange, let's say just 2 values, and then we just reshape it to let's say 2 by 1 matrix. If you do that, then still what will happen is, just apply the parentheses just to show that this should happen first. What will happen is there will be a column that will be added to every column in A, and that again will be happened through the broadcasting. So broadcasting is that powerful. Next, let's see the stack. So let's say this is A. Let's say we have B. That's another array. Let's say np.random.rand. Let's say that new array is 2 by 2. And again, let's say it is multiplied by 10, and np.round just to avoid the decimal points. Let's say this is B. Now A is 2 by 3 array, B is a 2 by 2 array. If I just concatenate them horizontally, I will get another array which will be 2 by 5. So C equals np dot h stack, horizontal stack, h stack, and I will call these A and B. One thing that you need to know is if you want to call this h stack, horizontal stack or vertical stack, these arguments A and B that you want to concatenate, you have to give them in a tuple, or you may want to give several values to concatenate together. Maybe you have 10 matrices to concatenate together horizontally. You have to give all these as a tuple inside. Okay, great. Now similarly, we can do a vertical stack if we want, one on top of the other, and we can call a concatenate function as well if we want. Third is a sort function. For example, if you want to use np dot, let's say A is np dot random dot permutation. Let's say np dot arrange. Let's say the 10 values. Let's say that's our A. Let's say this is A, and we want to sort this array. Oh, this is already sorted. Why? Is it sorted? No, it is not sorted. 1/4. It is not sorted. Yeah. Let's say we want to sort it. A dot sort. One way of doing that is just call A dot sort, and you are done. That's the value of A. Another way, which is sometimes more readable, although exactly the same, is to use a universal function using np dot that thing. That also is the same thing. Now sort by default sorts in ascending order. If you want to sort in descending order, then what you can do is you can sort a dot sort, for example. You do that in ascending order. Then what you do is you just reverse it, -1, and just copy that in a again. Now a will be sorted. Wow, sorted in descending order. Yeah, great. One more, just to give you one more flavor. If you create an array, for example, np.array of strings, for example, a, b, c, and another string is how are you, and maybe we have another string u785, and maybe we have another string 13er. Let's say that's a string. That is possible. As long as all the objects have same type, you can create an NP array. Now you might be wondering, what will do this sort function on A, because these are all strings? Well, the answer is it will sort the strings according to the alphabetic order, whatever the alphabetic order is. Whatever string according to the alphabetic order should become first, that will become first, and the other strings, they will just join. Yeah. So yeah. So that's about something that is not the numeric value. Okay, great. There is a few more things to come about NumPy array, and then we will be moving towards Pandas library that is built on top of NumPy array for better processing of data. Hope to see you in the next video. Okay, in the last video, we saw horizontal concatenation, vertical concatenation, sort function. We also saw some broadcasting and stuff like so. Universal functions, it should be speed here. Sorry, it should be speed. Universal functions are really speedy. I'm talking about NumPy. Whenever I start NumPy, I said it is fast, it is fast, it is fast. I never show you how fast that is. So let me give you an example. Let me just create an NumPy array with a lot of numbers, and then just apply an ordinary function. Let's say I want to add all the numbers in this array B. Let's apply an ordinary function that is not in NumPy, and then let's use a universal function .sum and see how speed difference is there. If, for example, we apply a universal function to achieve a particular task, how speedy that universal function is, because the vectorized implementation, as I told you, is much faster. How faster? Let's check that out in the Jupyter Notebook. That's a magic command, time it, that will tell us how much time this particular task has taken. And if you run this command, it will call this function again and again several times, and then will report an average value that will be much more stable than just calling once. After that, we will also write our own sum function using loop, and we will see whether that is even closer to a universal function speed or not. Let us just check the speed of universal functions. That will give you a look and feel of how much NumPy implementation is faster. So let's say we have an array, let's say B, np.random.rand, and let's say that array is huge, really huge. Let's say that's the case. Now what we do is let's say we call a function sum. So let's say we call a function sum. That's a built-in function in NumPy. That's a built-in function. That's a built-in function in Python, not a NumPy function. And then let's say we do the same task using NumPy universal function np.sum. That's the same as np.sum is the same as if we write, for example, b.sum. So whether you write b.sum or you use np.sum and b pass as an argument, both these things are roughly the same. So let's run it. It will take a while. It will take a time because okay, the sum function takes 307 milliseconds. That is not a universal function in NumPy. That's Python function. That is not written in NumPy. That is not a vectorized code, nothing. It takes 307 milliseconds to take the sum of the elements of this array. And it does that by applying 7 runs, 7 loops. However, the universal function takes just around 3 milliseconds, 2.7 milliseconds. How are you going to compare this 307 with 3? How much faster you are? Around 100 times you're faster. Yeah. This NumPy is literally faster. NumPy, the universal function, they're faster. Maybe you attempt to know that, okay, this sum function might be too slow. Let me write my own function to do that. Let me define my sum, and my sum just take an argument, let's say something, let's say G, and what it does is for, let's say S equals 0, what it does is for X in G, S plus equals to X, X plus equals to X, and then just return S. Let's say that's your function. Let's say you think that this is really a great function. Let's do that. Okay, let's compute the time for this. Time it, my sum, and let's pass the array B and see how faster this is. This is roughly the same as you're calling the sum function, but this np.sum, or the universal function, is way faster, way faster. So use universal functions, avoid for loops, avoid your own functions if the same task can be achieved through universal functions. Whenever possible, avoid loops when you are working with NumPy. That's a serious suggestion. Follow that, because the universal function written in NumPy, they follow the vectorized code. All the interpreted slowness that is deferred to the compilation layer, and the NumPy becomes really faster and shows its power when you are working on large arrays using the universal functions. So I can speak more about NumPy, but I have told you some basics of NumPy, and we end the NumPy here, and from the next video we will be moving towards a very fancy and beautiful kind of package called Pandas to handle data. And by the way, the Pandas library, the Pandas package, completely is built on top of NumPy. Everything that is there in Pandas is built on top of NumPy. So all the indexing and all kind of stuff, slicing and speed, all is there in Pandas that is due to the NumPy. So we will see one more package after Pandas, which is Matplotlib for plotting afterwards. And we'll do a project at the end using scikit-learn as well, just to wrap up all these things together. But for now, I'm ending NumPy here, and in the next video, we will start Pandas. Hope to see you in the next video. Okay, welcome to Pandas, a data science package that is very powerful of handling data, manipulating data, and used a lot in data munging and data cleaning and data pre-processing and whatnot. This Pandas basically is built on top of NumPy, so most of the features of NumPy is also available in Pandas. Let's dive in. This Pandas is a very fancy library, very fancy package that you can handle very large amounts of data in CSV files or in Excel files, wherever the data is located. The missing entries are there. You can handle all the data, you can manipulate all the data, you can prepare all the data in just a few lines of codes using this Pandas package. So let's just start Pandas package. There are two most important objects of Pandas. One is series, another is data frame that we will see later on. There is one more index, but the most important one is, or the useful one is series and data frame. So let's just define, first of all, you need to import Pandas package, import Pandas, and you can rename this as PD. That's the most popular renaming, although you can rename it any. And then you just say, okay, pd.series, and then just like a NumPy array, you pass the data that you want, and you can create your own indices. For example, just like dictionary, this A is a key value, This A is a key or index for this 0.25, this B is index for 0.5, C is index for 0.75, and D is index for 1. So you can supply your explicit indices as well. If you do not supply the indices, the default indices are 0, 1, 2, and 3. But you can define your own indices in the way you want. Now, once this data object is created, you can call the data values and you will find out the values. You can call data.index and you will find out the indices. Let's see in the Jupyter notebook, just to get comfortable with Pandas. First of all, import Pandas as PD maybe, or something else. So okay, that's imported. Maybe we can check what version we are working in. PD.version. The version of Pandas we are working in right now is 0.24.2. Fine, great. So let's create data or whatever variable, let's say A, as pd.series, and there we just give a list of some values, 2, 3, 4, 5. Let's say these are the values, and then we can give index as another list. Let's say the indices are A. Maybe the indices need not to be strings, anything, A, B, C, and let's say the index of 5 is, let's say, D. So now the series object, or the Pandas object series, is created. Series basically handles one-dimensional arrays. Later on we will see data frame handles multi-dimensional arrays, I mean more than one dimensions. Normally, typically two-dimensional arrays, but okay, A dot values. So let's call the values and you will get all the values inside the series. And by the way, this values array that you get, let's check what's the type of that array. What's type of that array? A dot values, what is that thing? That's a NumPy array. Wow. And what's the type of A itself? That will be a Pandas object. Great. So everything inside Pandas, the NumPy is playing all the role inside Pandas. Great. So now let's check the index, A dot index. That's also an NumPy. That's also an array of index type. That's a different. Actually, index is also an object in Pandas. That's an index type object with these kind of indices. We can access, for example, this A, just like we are working with dictionary. For example, A of A, that returns a value. We can change the values. We can add different. We can add more key value pairs. So just think like just think this data just like the dictionary object that we saw. These are the keys and these are the values, and this is one very good way of remembering what the series does and manipulating series the way we want. Okay, we can access A like this. We also can do slicing. Let's say we want to access from A to, let's say, C. Let's say we want to access all these. One difference is when you access like this, in the normal slicing using implicit indices, for example 1, 2, 3, or 0, the final index is not included. But if you access like so, using explicit indices that are there, the final index is also included. So that is one more fancy way of indexing using in this Pandas. Okay, great. That's a series object. By the way, we can create a series object by first creating a dictionary. For example, let's go back to our slides and see this example. Let's create a dictionary, for example, of grades. Let's say we have a lot of students with grade A minus, grade B minus, and let's create that dictionary. Then we can just create a series object or Pandas object by just passing this dictionary inside. We can make another dictionary, for example, and we can make another series object. So one way of defining the series object is just to pass the data as well as index. Another way is to just first create the dictionary and just pass the dictionary variable inside, and the series object will be created. Okay, that was just the introduction to series. We will move on and see more features of Pandas as we explore it more and more in the upcoming videos. Hope to see you in the next video. Okay, let's say we have two different dictionaries. Let's say we have a lot of students, and the A grade is defined to be 4 and the A minus grade defined to be 3.5. The B grade has a number 3. The B minus grade has a number with a numeric value that is 2.5, and similarly B grade has a numeric value, let's say 2. And then we create just a series object using this dictionary. Let's say rather than just numeric values as GPAs or something like so, let's say A grade also is defined at 85 marks in total. A minus grade is defined at 80 marks in total, and similarly these. And then we create another series object, let's say named with marks using these pd.series. So let's go to Jupyter Notebook and just play a little with these dictionaries and build the series object. Let's say marks, or let's say grades dictionary equals, let's say A grade is has A grade has number value 4 or GPA value 4. Let's say we have a B grade with GPA value, let's say B is, let's say 3.5. Let's say we have C grade with GPA value, let's say 3, and let's say finally we have D grade with GPA value, let's say 2.5. Let's say that's a dictionary. Okay, what we do now is we create a grades series object, let's say using pd.series, and just parse this grades underscore dict. Now this capital A, capital B, capital C, and capital D, they will act as indices, and this 4, 3.5, 3, and 2.5, they will act like values. So for example, if we call that and just now call grade.values, so we will get, for example, oh, what is that? That just values. Let's say we get this grades.values, and we get all the values that are available. Similarly, if we find grades.index, we will find out A, B, C, and D. Let's define another dictionary, for example, marks dictionary dict, and that is, let's say again A, the total marks are 85 for the A grade. Let's say for B grade the total marks are, let's say 75. Let's say for C grade the total marks are, let's say 65, and for D grade, let's say the total marks are 55, let's say. So let's say that's another dictionary. Now let's create a series object pd.series let's say marks dictionary. Yeah. So now again we have, if we just write this marks just like so, you will see the marks A is 85, B is 75, C is 65, D is 55, and all the values, they are integer 64 kind of values. Now we can access, now we can play with this marks. For example, if we just want to access, for example, what are the marks between, let's say, for example, what are the marks given at A? We can access that, we can change that, we can just play like a dictionary. What if we, rather than using the index A, we use, for example, slicing? We want to start from the very beginning, and let's say we want to go to 2. What will happen? Let's see. Yeah, so the slicing is there. For example, if you want, these are explicit indices, A, B, C, D. These are explicit indices, and they are there. For example, if you can slice the data using explicit indices that you are given, or implicit indices that are the default indices. The first value indexed at 0, the second value is indexed at 2, 1, and so on. So you can do that as well. One catch here, for example, that we will see later on, there may be a problem that your explicit indices, they are also numeric, and then you do the slicing like so, then the series object may be confused whether I have to use the explicit indices or implicit indices inside. We will see how to resolve that issue, but this pandas allowed to use explicit indices as well as the implicit indices. Okay, we were here. Sorry, so we were here. So we have created these grades, a series object, this marks as a series object. The series object is good for one-dimensional arrays or data with just one-dimensional list, or dictionary kind of with just one dimensions. Later we will see data frame that actually is actually the extension of can be look like as an extension of series towards more than one dimension. We may have, for example, two-dimensional arrays or two-dimensional data structures, something like so, and we will be seeing this data frame, which is much more powerful, particularly for reading data from files and manipulating it and stuff like so. We will see that in the next video, data frame, that running form of data frame in the next video. Hope to see you in the next video. Okay, in the last video we were discussing series, and I told you that data frame is basically if the data has if the data is in a form of different columns, for example a record as an array, then you have another record, then you have another record, and each element in that record is a different attribute. So this particular way of two-dimensional data is very well handled using data frame inside pandas rather than series. So but you can make these data frame object using different series objects. For example, you have a grade object, that grades object that we created last time. You have a marks object that we created last time. Let's build a data frame using these two and see what it looks like in Jupyter Notebook. Let's see that. So remember, we have a marks series object, and we have a grades series object. Let's now make grades. Maybe the name is grades. Okay, the name is like grades. Okay, so grades object, this one. Let's make a data frame. Let's say D, or maybe whatever name you want to do, data frame with, again, that data frame can also be defined using a dictionary. Again, now we have, let's say, marks is the key for data marks, and grades is the key for data grades. Let's say we define a data frame like so. And now if you see, if we just display this D, we get a very beautiful look and feel of, this A is the index, A is the explicit index, at index A, the marks is 85, the grades are 4. At index B, the marks are 75, the grades are 3.5, and so on. That looks like so. Not only that, you can just transpose it like you have transposed the NumPy array, and you will get the flipped variant or the transposed variant if you want. Great. So that's how, and you can have, for example, more dictionaries to concatenate together, and more columns will be added here. And that's what the real data looks like. It has a lot of columns, which normally are attributes, and each row is basically one record or one sample of the data that you want to work on. So this data frame is really ideal data structure for working with files, having a lot of records, and you want to manipulate that data and stuff like so. So yeah, so one more thing, let's access the D, for example. Let's print D. That's the D. Let's access the values inside D other than no. So what are the values? So the values inside D is completely, again, a two-dimensional array that is completely like so. So for example, if we want to access this particular element 65, that is row number 3 and column number 1, excluding the indices. That's row number 3 and column number 1. So we can access that particular value, d.values, just assuming that's a two-dimensional NumPy array, row number 3 is 2, indexed with 2, and column number 1 is indexed with that, and we will be able to access 65. Wow, great. So that is there. There are more things that are available. D dot, for example, columns, D dot columns. It will give us what are the columns. The columns are marks and grades. There are other properties, and there are other several properties that we need to know. RS, for example, this there we define this as d dot index and stuff like so. Okay. One more thing that you need to know is we right now we have, let's say, D, that is this one. That's the D. Let's say we want to add another column here. We want to add another column here. And that is the name of that column is scaled marks. And the scaled marks are, what if we have computed marks rather than from 100? What if we have computed marks out of 90? What are the scaled marks out of 90? So one way to do that, and very quick way to do that, is just like a dictionary, again like a dictionary. You just add a new key, let's say scaled marks, that's a new key, and the value is simply all the marks column divided by 90. So is that true? No. Divided by 90. If we have just computed all the marks by 90, and then how can we compute the marks from 90? It is rather than 100, it is from 90. I guess how can we compute the marks from 90? If you want to compute the marks from 90, I guess they will look like divided by 90, and maybe 100 is multiplied here. I guess maybe the formula, I guess that's what it is, I guess. Let's see. So now if you see D, there will be another column that is there, and it does something else. Anyways, I mean, it does something that, yeah, so something. Anyways, so we have just computed this. We just inserted that column inside that. I mean, that is a processed version of these kind of values. Maybe we have added this column in a very wrong way, and later on we suggest that, okay, we should delete that column. Well, that's very simple. Again, using the concepts, again, just like the dictionaries. Delete this, and this column is deleted from data, and you are again with the data that you had. So you can add columns, you can delete columns, and indexing is really fine. I mean, indexing like masking. Let's say you want to pick, for example, or you want to pick the data frame such that you want to pick all the records such that the marks are greater than, let's say 70. You want to pick all the records where the marks are greater than 70. This is that simple. All the data will be copied into G with this condition, and this condition can be arbitrarily complex using ands and ors and combinations and all that stuff. And you have seen this kind of stuff in NumPy as well. I mean, this is called masking. Great. So that's available in Pandas as well. Okay, so that's how you can index. In the next video, I'm going to basically show you one type of problem that normally happens in real data, that is the missing value problem. Sometimes you read a data and some of the attributes or some of the row column pair values, they are just missing. I mean, they're not available due to certain reasons. How can you handle those values, and how actually Pandas suggest you to handle those kind of missing values, which is sometimes called NaN values or none type values also. They mostly used interchangeably in Pandas. So in the next video, we are going to handle or see how to handle missing data in Pandas. Hope to see you in the next video. Okay, in the last video, we saw data frame object, and we saw actually how to add and remove columns, how to process data, how to index, how to actually mask, or how to apply conditions and selections in Pandas. We saw that very briefly, but in this particular video, we are going to see one kind of missing value, sometimes called nan, or not a number, or maybe not anything, or sometimes this none type, none, which is the default return type of any function in Python. This none type is also sometimes in Pandas is treated as nan, or nan is treated as none, or interchangeably anything. Let me give you what do we mean by that. Let's say we have two dictionaries. Let's say one dictionary is A with key value A, and the value is 1, then B, and the value is 2. Okay. The other dictionary is B and C. So for example, that is one record with columns A and B. So A and B are the columns. On the first record, the value of A is 1 and the value of B is 2. Now let's say we want to insert another record in the same data frame. Now the value of B is available in the second time. The value of B is available, which is 3. And the value of C is available, which means a C column is added now. But for the value C, the first row value is not available. So we will say this value is missing here. But in the second row, we have 4. Similarly, the value of A is missing for the second row. And that is a missing value, which is sometimes called nan. So these are missing values, and they are typical when you are working with data and you're reading data and you're getting data from somewhere, or large files and stuff like so. So Pandas give some methods to handle these kind of this kind of situation. Let's say A equals PD dot data frame, again a dictionary. Let's say we have A 1 and B, let's say 4. That's the first row or record. The second record, let's say, is another dictionary. Let's say B is -3 and C is, let's say, 9. Let's say that's our data frame A. So now if you print this A, if you see the data inside A, you will see, oh, what's the problem? A is this, and B, have we applied something in a wrong way? Let's see. Yeah. Oh, we have to create a list. That's the, okay, we have to create a list of it. You have to create a list of dictionaries. That's the proper way of calling it. So we missed just the syntax list of that. Okay, great. So now we have this A, we just call that A, and this value is missing and that value is missing. And in large data files, this is typical. I mean, there are a lot of values that can be missing. One way that Pandas applies to handle these missing values is to just fill these missing values with some fixed number. For example, there is a fill NA function, and let's say you supply a 0. That means wherever there is a not available or not a number value, fill that with 0, or maybe any value you want to fill that with. So that is one way to do that. And now if you see, the value of A is all the non-values are filled with that. Another kind of function that is available in Pandas that is sometimes used, that is drop NA. That function drop NA. What that does is it drops all the records that contain a missing value. Sometimes if that is feasible, I mean, dropping all the records that contain missing values, if that is feasible, then go for that. But if the missing values are a lot and they are spread over a lot of rows, then dropping all those kind of records, they will create a lot of data loss, and and then it become really important how to handle these missing values.0wever, you can fill the missing values using fix value, or you can drop them. And later on we will see in scikit-learn that there are other ways of handling the missing values as well. You can fill each column missing values in each column using an average, or using, for example, a regression. There are ways to handle these missing values. But in Pandas, these two functions are right away there. You can fill all them with a fixed value, for example, or you can drop them and you are ready to go. Okay, great. Next, we are going to see, as I mentioned earlier, what is a confusion between, what if there is a confusion between implicit and explicit indices, and that I will discuss in the next video. Basically, just to give you a look and feel, what if the explicit indices you supply, they are 1, 3, and 5, and what if you call this particular command 1:3? Will it call the implicit index or the explicit index? That's a problem. So we will see, because 1:3, 1 and 3, they are also explicit indices, and whether this 1:3 is referring to the implicit indices that are default indices, or they are referring to these indices. So this confusion is there, and we will see how to handle that confusion using this lock LOC function and index lock ILOC function. We will see that in the next video. Hope to see you in the next video. Okay, in the previous video I mentioned a confusion that can be there if you have supplied the explicit indices that can conflict with implicit indices. In particular, for example, if this is the series object, or maybe a data frame object, if you want to, if for indices, let's just think about the series object. It has these values A, B, C with index 1, 3, and 5. If we, for example, access a particular element, let's say data with index 1, that means the explicit index for sure. But if, for example, we slice the values, for example 1:3, the default behavior of slicing, if you give the numeric indices, that is to use implicit indices. And by implicit indices we mean that what is at index 1? At index 1, this is B. So B will be printed, for example, or B will be fetched. And then you move to 2, which is C, then C will be fetched. And these are the values that will be printed. But the behavior might be different. You might be expecting to use explicit indices, which means access 1:3. And when the explicit indices are used, the last index is also included. And in that case, you might be expecting the index 1 is of A, so A should be printed, and index 3 is of B, and B should be printed. And this confusion might be there if this is there. So to handle that, there are two functions. One is called LOC, and another method is called ILOC. Whenever you call LOC, that means you are using explicit indices. I mean, you're forcing to use explicit index. And whenever you call ILOC, that means you're accessing elements using the implicit index whatsoever. So let's practice this and see the confusion. See the detail of this kind of confusions in here, Jupyter Notebook. So let's say we have a series object. Let's say A equals PD dot series. And let's say it has values as A, B, and C. That's the value. These are the values, and index as, let's say, 1, 3, and 5. Let's say these are the indices. Let's say this is A. Okay. Let's say we access A using 1. That means the explicit index, and that is this. Let's say we access using a slicing operator. Now this will use implicit indices, and it will access it will access these B and C, because 1:3 using indices, implicit indices results that. And we might be expecting that use this kind of stuff. So if we are really interested in using explicit indices, what should we do is we should call the lock function, a lock, and then 1:3. That means use explicit indices. That is to remove the confusions. Now it will use the explicit index 1 and 3. And if, for example, we are interested in using implicit indices, then it is good to use ilog function. Yeah. Now 1:3 is to use implicit indices, and the implicit indices are like these. So and like in series objects, you can do the same in data frame objects. Once you are using log and ilog, then the further indexing inside these square brackets is exactly the same like NumPy. So whether you use log or ilog, the indexing mechanism is exactly the slicing mechanism is exactly the same like you have used in NumPy. I mean, all indexing that stays the same. Log means you're using explicit index. Ilog means you are using explicit implicit index. Let's say, for example, we have our data frame, I guess D. That's our data frame available to us. Let's say I want to access d.ilog. Let's say I want to access the second row completely. The second record, the record that is indexed at, index at 2, which is the third row completely. Let's say I want to access that. Now this 2 is acting as, for example, if you see the second row or the row at the second index, which is the third row, that is completely this, and it returns that. Once you have used ilog, for example, and mostly people use ilog, sometimes log is also required, but ilog is just to explicitly mentioning that I'm going to use the implicit indexing scheme. Again, you can consider whole that thing as a matrix, and once you have applied this ilog, then you're free to play with the indices like you play with two-dimensional arrays. For example, I want to reverse, for example, all the rows, and I want to reverse all the structure, for example. Let's say I want to do that, and you can see everything is reversed. I mean, all the indexing, like NumPy, all the indexing is there in Pandas. I mean, once you have used ilog inside, is just remember the NumPy indexing and everything like so. Okay, so that's the log and ilog function. In the next video, we are actually going to just practice the Pandas to actually work on a data file that is saved as a CSV file. So we will show you how to actually manipulate, read, and write the data and play with the data, the real data that is there in some CSV file, and how Pandas will help you to manipulate the data very efficiently and very quickly. So hope to see you in the next video. Okay, in this particular video, I will be talking about a real data set. The data set I have chosen just to show you some functions that are available in Pandas to work on real data set. The data set I've chosen as a COVID-19 data set that was available in Kaggle, and it's a real data set that contains information of victims recovered, the total number of recovered people per country, per province, the total number of died people, and the total number of reported people per date available. That data is available. Let's see the look and feel of that data in a file just to see what kind of data we are talking about. So let's say this is our data. This is a serial number column that contains just the record number. That's a column called observation date. That's a date. That's a province or state. That's a country or region. That's the last updated, when the record is updated, what's the time, and how many confirmed cases were there at that date, and how many deaths at that date, and how many recovered at that date. As the date is moving on and on, you will be seeing that the number of confirmed cases and the number of recovered cases, they will be increasing. Maybe the number of deaths, they also increase. So let's see this data. Let's read that data using Pandas and do some manipulation of this data and see the look and feel of that data in Jupyter Notebook. Let's go to Jupyter Notebook and see. So first of all, I need this Pandas library. I imported that. Maybe somewhere I need this NumPy library as well. I'm also loading a scikit-learn sklearn library because I want to use the impute function just to handle the missing values. It is just more powerful to use the sklearn library. That is also a data science library, a package that is particularly a machine learning library or package that actually gives a better support or a larger support of handling missing data. Although here I have used this sklearn function just for an example, but I could have used this data frame fill NA function or something like so, but I'm just using that one. Okay, after importing all these, what I did is I just called pd.readcsv function and I load that data, and then I did this stuff one by one. Let's spend some time on all these commands one by one, and let's see in Jupyter Notebook what is happening. Let's go to Jupyter Notebook and actually read that file and do whatever we are doing here. So first of all, import NumPy that is already imported. Import, for example, Pandas that is also already imported. Then from sklearn.impute, import simple imputer. So let's use that, or let's do that. From sklearn.impute, import simple imputer. Okay, import that because that's a new thing. We need to import that. Now read the data, for example, data frame in df. So df equals pd.read csv. There is a CSV file, read CSV, and it contains the path of the file. The path is located in my directory. It is located at this particular location, COVID, and the name of that is COVID_19_ data. So COVID_19_ data.csv. So let's read that file. The file will be read. If you just see that there is a function, let's say head, that gives the top records or the records that appear just in the very top. That's what the data file that I was showing you in Excel. It is showing just the first 5 records. I can show the first 10 records, for example, just by calling the head function in this particular way. Okay, great. Let's say I just want to remove this serial number because I think that is not required. And let's say I want to remove this particular column because that is also not required. There are multiple ways of doing that. I can call a del function on this, and I can call del function on that. But there is another way of doing that by df.drop, and in that you just give the columns that you want to drop. One column is serial number, I guess. What's the column name? That's SNO. So you want to drop that column, and then you want to drop this particular column with heading last update. So that is last update. So that is, I guess, what is there. Access1 in place true. So access1 is just mentioning do that stuff with columns. In place equals true. That actually is telling that whatever this operation you are going to do, reflect the changes in this df frame. If we do not write in place true, it will do everything and return onto a temporary variable or underscore variable or whatever we are saying, but the data frame will stay unchanged. So in place true means do that changing in df variable itself. So now if we see df dot head, let's say, it will no longer be showing us the serial number column and the last updated column. What next we can do, we may want to rename this name to just date, for example, this to maybe another. Let's rename all these columns using a rename function. df.rename columns equals to, and then we have that dictionary again in place equals true. So let's use this rename function, df.rename. Let's say that, and here we have columns, if I spell right, columns, and then that is dictionary. What columns you want to change? I want to change observation date. I want to change that to simply date, let's say. And I also want to change province slash state to simply state or province, let's say, simply that. And I also want to change this country slash region to simply country. So maybe I want to change this country slash region to simply to country, country, country. And I want all that should be happen in place. So in place equals true. So after that, if you run that on this particular step, and now if you see the state of df, you will get like so. Okay, these many. So date, province, country, confirmed, deaths, and so on. So this is much nicer form than earlier. Moreover, we may have a lot of missing values. Oh, one way, this date format, the date format is not in a format that Pandas internal date format. So let's convert the date format into the internal Pandas date format using two pd2 datetime function. So let's say df date equals to pd2 datetime, and convert this df date in that particular format. And now if you run this df.head, you might be seeing the date format in a different way. See that? That's a date format that the Pandas is expecting. Now that is just showing some records. If you want to see more records, we can see those. Let's say I want to just count, or let's say let's just describe all the data. df.describe. There is a describe function that describe most of the statistics of the data. I mean, the total count of confirmed cases are these, the deaths are these, recovered are these many columns are there, these many values are there. The mean is that, and standard deviation is that, the minimum 25, and these are the statistics. Let's say there is another function, info, df.info. If you call that function info, it will give us the more information about the null entries and the non-null entries and so on. For example, if you see the total number of data columns are 6, the total number of records are 6, 1, 6, 2, the date entries is always available, the province entries are only 3700 available, the rest entries are null entries. So province entries, most of the entries are null entries and they are there. Maybe we want to drop those, or maybe we want to impute those entries and stuff like so. But there are null entries that are available in the province column. Some of the province values are no longer available. Let's see that here. For example, this is not available, this is not available, this is not available. And that's what the real state of the data is. This is not available, this is not available, and so on. So this can happen. Okay, next what we do is we actually use this simple imputer just to impute the missing values. One way is to do that using simple imputer from sklearn. Another way is, as we already know, just df.fill na with, let's say not available, with, let's say, string, some string, not available, let's say that string. And with that, if you fill na using that, now after that we will be having all that data, the missing values will be filled according to, let's see, some missing values, because in the province there were some missing values. Now you can see, for example, let me go on, yeah, so not available. We can use that, or we can use a fancy kind of thing that is available by scikit-learn and so on. Okay, after that, if you now see the info, now you will not be seeing any null value. All the columns are there. This was not in place. So .fill na, that is, and let's change the df with it. So this doesn't happen in place. So df, just change the df. Okay, df changes. Now, if we now call the info, there is no null value anymore. Yeah. So I end this video here. In the next video, I will show you this group by command to just see these kind of stuff in a more detailed way, because this particular video is getting lengthier and lengthier. I'm stopping here in this particular location. Next time I will show you the group by command in the Pandas data frame, and I will show you what that does. So we will explore all that code that is written here, and we will in the upcoming videos, when we will see the plotting and Matplotlib, we will be using the same data file to work more and to get more insight how this Pandas and Matplotlib and NumPy in combination, how they can actually play a very important role in analyzing a very large real data files. Okay, so I end this video here. I will start the next video right from this command, and will tell you what is happening, what is this group by command. So hope to see you in the next video. Okay, in the last video we were discussing this COVID-19 file, and we reached here, but we didn't use this sklearn imputer. We just used the fill na function of data frame. Now let's discuss this group by command, or a query in Pandas that is much more visible. Let's say our goal is now, for example, if you go back to Jupyter, if you see your data df.head or all, let's say df.head, let's say 10 records. If you want to see that, there are so many records, let's just see 10. Let's say what you want to do is you want to just see how many total confirmed cases are there in each country, regardless of their date. And for example, you want to just see all the confirmed cases, all the deaths, and all the recovered cases in each country for all the dates and for all the provinces combined together. One way to do that is to write a group by command. For example, let's say df2 equals df.groupby, and in group by, what you see is for what kind of columns you want to group all this data. So for example, you want to group by country, so that's your grouping. Now after grouping, what do you want to see? What kind of for example, the values you want to see, because now you're grouping. Well, after grouping, I really want to see, because date is gone. Once I group all the dates, they are grouped together, all the provinces that are grouped together. So what I really want to see is just the country. And I want to see the confirmed cases. So pick all these records, confirmed, and then I want to see deaths and recovereds, for example. If I want to, deaths, and let's say then I want to see the recovered cases, RE, and just I want pick group all the countries together, group all these things together, and add all the records under each country. So sum all of them, and maybe we want to reset any index if it is there. So for example, reset index. So that thing. So after this query, for example, this group by query, what will happen is this df2 will contain a summary of the data with respect to each country and the total. For example, in this particular country, the total confirmed cases are these, all the confirmed cases till now, and the deaths are these and recovered as these for this country. For each country now, each country is describing. Australia, for example, till now, Australia has total these confirmed cases, these total deaths, and these are recovered cases, and so on. So that is if we want to group all these with respect to country. What if we want to group all these with respect to country and then date, for example? So first we want to group them by country. So country, and then for each country display all the dates, and then do the same stuff. The query will stay almost the same. A group by command will stay almost the same with one kind of let's say we want to first group by country. Once it is grouped by the country, then I want to group them by date, and now I want to see all the results in the form of I want to see the date as well. And what will happen now is for each country, its trend with respect to all the dates that will be displayed here. So let's see df2 now. df2. So if you see df2 now, you can see, for example, this particular country, it has just one record, then this country it has one record, then this country for this date has this record, for the same country another date has same record, and all the date is also sorted. I mean, now you can see all the records in a very incremental way. So that may give you a very good look and feel of what is happening. Or for example, another thing, what if you want to for example find out all the records, you just want to find out all the records. That's df3, for which the confirmed cases, for example, the confirmed cases are more than 100. Let's find out all the records. Let's just pick all the records for which the confirmed cases are larger than 100, and let's copy all these records, just those records, in this. So if we do that, we have df3 available, and we have df3 this. I mean, these are just the records in which the confirmed cases are for sure larger than 100, just those. Yeah, so we can do, I mean, a lot of data analysis, the real data analysis, a lot more. I've just shown you a very small snapshot of what we can do with Pandas on the real data set. I mean, there is a lot more that we can do with this Pandas library on real data sets, on multiple data files, combining them together, joining them together, seeing their correlation, a lot of stuff. And this Pandas really is a very, very fancy and very high-level library, very high-level package to work with data. So due to time limitations, I'm just ending this Pandas here, although there is much more to explain in that. But in the next video, we will be jumping towards Matplotlib. Just we will see some functions of Matplotlib, and we will see very briefly how can we plot, how can we analyze data using visual graphs or stuff like so. So that sometimes this visualization of different attributes of the data give very good insight to the data. Wherever possible, if the visualization is possible, if the data dimensionality in a way or the visualization techniques are in a way that you can visualize the trends in the data, that gives you much better insight than the numbers or statistical results. But it completely depends in what situation you can visualize the data. There are situations, high dimensional data, for example, is not always visualizable. So in those cases, the statistical results or the numbers may play a more important role. But in many cases, visualization give a very good initial insight into the data, and the design process can become very, very fast if you know something about the data. Whether you get that information by visualization or by other statistics or whatever. So in the next video, I will be just explaining some very few functions of Matplotlib, and then we will be exploring the same file, and we will be doing some stuff using the plots and Matplotlib, and seeing the trends of death rates, seeing the trends of, we will be playing with this file a bit more using Matplotlib as well. So hope to see you in the next video. Okay, in this video, I'm going to discuss Matplotlib, a very powerful package for plotting graphs and scattered plots, line plots, and 3D plots, and plots on the globe and whatnot. Very, very powerful tool. The most important module in this Matplotlib, or the most popular module, or the most used module, is pyplot. So we can import matplotlib.pyplot as PLT. Another way of writing the same kind of stuff is we can write like from Matplotlib import pyplot as PLT. So either way is fine, whether we write this as a dot notation or that one, that is fine. So NP is for NumPy. So let's create some points. Just make our first plot. Let's make some points starting from 0. Let's say all the points starting from 0 till 10, and let's create 1,000 points in between. One way to do that is to use built-in function or a method in NumPy, which is linspace, or linearly spaced points starting from 0 ending at 10, and there are 1,000 of those points. Let's say this is our x and this is our, let's say, y, which is np.sign. This sign function is actually will apply element by element on this NumPy array, and then this PLT will actually plot x comma y, all the points in front of you. So let's go to Jupyter Notebook and actually see this Matplotlib in running form for the very first time. Oh, we have seen this Matplotlib when we saw np.random, we plotted a histogram. Wow. So this is not the first time. We actually have seen this once before. So import matplotlib.pyplot as PLT. That's your import command, for example. Now PLT is available. Let's say x is np.lin space. Let's start from 0, go to 10, and generate, let's say, 1,000 points. Let's say that's your x. Y might be your np.sign x. Let's say that's your y. And then what you do is you say, okay, plt.plot x comma y point by point, and then you press shift enter. That's it. Oh, this plot is there in front of you. That simple. That simple. Can you imagine? This is that simple. Yeah, this is that simple. So plotting, this is a line plot, for example. If we want a scatter plot, we can say, okay, plt.scatter. There is a scatter function that allows us to plot all these in points form rather than these line form. These are a lot of points. That's why you're not seeing these scatters. So let me take this x as fewer. Let's say, let's take x as let's just take few points. Let's say just 30 points, and let's see the corresponding 30 points. Remember the indexing of NumPy arrays? I'm just using that. So now use the scatter plots, and you have this. Oh, that's scatter. Maybe we want to use, let's say, start from the very beginning, go to end, and pick every, let's say, 10th point, and do the same with y, just to see a plot in a better way. Just sample some points. So that's the scatter plot. It is just like, I mean, the points and so on. It is not a continuous plot like the line plot. It's a scatter plot. We can annotate this scatter plot. We can change these colors to any color we want. For example, we can have a property. For example, color is equal to, let's say, red, and everything will become red. Yeah, so that's red. We can have, I mean, we can label it, we can X label it, we can Y label. There are a lot of properties. But the main point is, plotting is that simple. Plotting is that quick using Matplotlib. So yeah, this Matplotlib is really, really powerful. We have just seen a snapshot, just a plot function and a scatter function. There are a lot of properties to be set. There are a lot of things to be considered, and we will see actually one lengthier code on this COVID-19 file. And we will actually analyze the death trends and the confirmed trends and some trends that and we will plot them and see the trends really using Matplotlib. So but before that, let me show you that if you call this plot multiple times, for example, maybe with different colors, then you will be having a lot of curves on the same plot, for example. So for example, let's see plt.plot x comma y, let's say with color, let's say color equals to blue. You can write blue the whole, or you can write just b, that's fine. plt.plot x, and let's say np.cos x, and the color you are interested in, let's say the color is let's say green, and that's perfectly okay. And that will give you two plots in the same figure sort of, and you can just good to go. Well, yeah, so that more you can, for example, you can plot with a green color and you want the solid line, or you want for example cyan color in a dashed line, or you want a dash and dot black line, or maybe you want a completely dotted line in red color. So there are several things that are available in Matplotlib. This is just a very simple snapshot, and I have given you a very quick start. And actually the whole point is using MATLAB is that quick. I mean, you have your data, you just plug in their data, you just call the plot function, and you're good to go for analysis. Okay, in the next video we will actually walk through the COVID-19 data set, and we'll actually analyze the trends and the death rate trends for each country individually, and then we will see the death confirmed and the recovery trend of the overall world till the 16th of March, till the date the data is available. So next video will be actually you will see the running form of Pandas and Matplotlib together. So hope to see you in the next video. Okay, I already have shown you the COVID-19 file, and here I have a notebook on that uses Matplotlib and Pandas to find out the deaths, confirmations, and recovery trends using different plots. So let me import all the packages that I need. I need a pyplot function from Matplotlib. I need Pandas somewhere. I need NumPy, and I'm using a simple imputer here for missing values. So let's run this. Let's run this command, and yes, everything is imported. Now let's load the data that I have shown you earlier. The data is available now. And let's run this thing that is the first 50 records. Yeah, remember that? Yeah, so that's the data that is available. If you just want another view of the data, that's the data file, which is COVID-19 file, and it has observation date, province, country, last update, confirmed to date, death to date, and recovered to date for each country and for each province individually. Okay, great. So that's what we have now. What we can do is, now let's drop the serial numbers and last update using in place and rename the columns that we did already in a previous video as well. Let's convert the date into the Pandas built-in date frame. Okay, let's use the scikit-learn imputer, sklearn imputer, using the constant strategy. There are a lot of strategies there. Let's use the constant strategy. And this pd.dataframe impute.fit transform, that will help imputing all the missing values with a constant strategy imputer. So that's there. Okay, next let's apply this group by command and group all the records using country for each country, and for all the dates let's sum all the records, let's sum all the values of recovered, deaths, and confirmed using this. But now let's first country and then all its date, then the second country, then all its dates, and so on. We have seen that in one of our previous videos. Just running that again just for a double check. So that's what the data state is. So country 1 all its dates, country 2 all its dates, so this country has a lot of dates, then another country, and so on. Next, let's see how many countries are there in total, how many unique countries are there. So what I do is I find the column, I actually pick the column with country and call a unique function on that, and that gives me all the countries without repetition. And I just compute the length of countries, tell me how many unique countries are there in this data file. There are 171 countries. So now my goal is for each country, I want to see what is the trend of with respect to the date, as the date is moving from the first day till 16th of March. What is the trend of death patients? What is the trend of recovered patients? And what is the trend of confirmed patients as the date moves on? So because we have 171 countries, so let's loop over each country again and again. Let's loop over. What we do is for IDX in the range of this, that's a loop, you remember that. And what I do is let's find out the indices where the country is like this. Let's find out the index, all the indices where the country is like that. Then what I do, I make a scatter plot that with starting from this and that. I just pick the confirmed cases, and all the confirmed cases for this one country, I just pick those, and I do that using this scatter plot. Then I use another scatter plot just to get all the recovered cases. Then I do another scatter plot to get all the death cases. And then the title of my figure becomes the country name. The X label is the days since the first suspect. The Y label is the total number of cases. The legend command actually will be there, that will show what each that is. So these kind of labels that are we writing here, they will appear in the figure. Then we force them to show that in each iteration, show the so this will show the trends of confirmed, recovers, and deaths for all 171 countries one by one. So if we run this command, we'll be having 171 plots in front of us. Let's see all of those one by one. So yeah, so this is for the country, it has just one such thing. This is for that. This is for Afghanistan. As days moves on, the confirmed cases that are written in blue, they are moving up. These are the number of cases. These are the number of days since the first day. And the green is the number of recovered cases. For Albania, that's the trend. For Algeria, that's the trend. I mean, these are each and everything is a separate. That is for Argentina, that is for America. This is for America till the 16th March, by the way. Today, the news says that America is really in a dangerous position. Anyways, that's for Australia till the date. We have the data that is for Austria. Yeah, so these are all the trends for all the countries. You see, I mean, the Matplotlib, how powerful that is. Although I walked through this code very quickly, but you can see this video again and again and check how that happens. Yeah, so that's what this is for Finland. Oh, Finland is also in trouble. So France, okay. So that is for Germany, and yeah. So all the countries that are available in dataset, they have these kind of plots. This is for Hong Kong, and this is for India. and this is for Italy. So Italy is yeah. So that's it. So that is for each country individually. What if we want the overall trend, or the overall confirm and the deaths and the recover trend for all the world together? So what I do is I group all the data with date. So I pick the first date and add all the records, then the second date for all the records for all the countries and so on. And then I plot the trend using the scatter plot again, confirmed, recovered, and that's for all over the world, and see the trend where the world is moving. So that's the trend of the world. As the days are going on, these are the death trend, that's the recovery trend, and that's the confirmation trend that is moving on. Although I walk through over this notebook, the notebook will be available to you. I walk over this notebook very quickly, but the goal was really to show you I mean, that was a file. May not be that informative if you see that in Excel, but now it makes much more sense. When you see these plots, you know what is happening and you have an insight in the data. And later on, we may want to predict, we may want to make predictions. And the next date, what is going to happen, we may want to predict using this plot or using some machine learning library like scikit-learn or TensorFlow or something like that. Okay, so that's it. I can talk much more about Pandas, NumPy, Matplotlib. There are so many other data science packages, very important packages. One of those is sklearn. That is for machine learning, basic machine learning. Then there are other packages like TensorFlow for deep learning, PyTorch for deep learning. There are a lot of packages with a lot of specialities in data science and stuff. I just discussed a few of those, the most important of those, to manipulate the data, to make predictions, to make classification or regressions. One way is to go to sklearn or scikit-learn, and if the data is huge and you have a lot amount of data and you have good expertise over deep learning, then you should go to either TensorFlow or PyTorch. These are the Python packages that are available for predictions, classification, regression, and a lot more. But either way, whether you're going to use scikit-learn, whether you're going to use TensorFlow or PyTorch, either way, you have to use Pandas, NumPy, and sometimes Matplotlib to pre-process the data and to make the data ready for these kind of libraries to perform predictions, either in the form of classification or in the form of regression. So this whole course was about for beginners who want to learn Python. Specifically, I discussed a lot about Python in general. Then I spent some time, not a lot amount of time, sometimes on exploring the data science packages as well. But I mean, there is no end. We can explore more. We can talk about the packages more. We can talk about other features of Python more. A lot of I mean, input formatting, output formatting, modules, packages, standard template library, file handling, internet access, database. I mean, this is a whole universe. I have discussed a few things for beginners, but these few things were very carefully selected for data scientists. If you have this course available to you, as you have gone through all the course, you now have a very, very good understanding, and now you can move towards further advanced courses towards data science, and you will be ready to implement the concepts in Python using the packages I have discussed so far. So I thank you all, and good luck.